They do have I'm trying to think of. Oh, it doesn't. They had one medal that was something expensive and exotic. I don't remember what it was though. No, they don't have carbon fiber yet.
No Tom Crowley this year?
Yeah, I like the heavier lower piece, the lighter weight top piece. Because it's easy to, it's not too hefty, but it's
Right.
yeah. But some people hate this, so they want like titanium, so our middle hands don't cramp. It kind of depends on what you like. Yeah. There's a cool pen. I have one. I should have brought it. It's they call it the Bolt. It's a bolt action pen. It's just like a rifle. It's the same mechanism. You push a knob down, you twist it, and it locks in. That's how you keep the thing out. So the only mechanical part is this spring. So it's the only thing that would ever wear out. It's just an actuation instead of a clipper. Just like a wire.
I mean, it's
No, I reached the stage of all sections of my life. That's just where you talk. Just one all. Yeah, they are.
One comment, we are broadcasting live on our website. People are already connected to that link. There is a live streaming widget on our website, and that points to YouTube Live connection. And then people, while watching, they will probably ask questions if they would. So speakers, I will collect questions if they are, and I will send them to the speaker. The problem is there is a delay about 30 seconds between the stream and the video, what's happening in the stream. So there will be a little waiting for questions to come and answers to get back. One other thing about speakers, if they are in the room, the camera, which is here, is taking images from pretty much this spot to this other spot. All the frame is in the image, but the speaker, if it walks through this distance, that would be great. There are two microphones, one is here, which is the best, and there was one in the camera, so we'll have like a spatial feeling about the sound. Hopefully the sound will be better than last year. That's pretty much all.
Is that a wireless mic?
No, nothing is wireless here. Good question. There are cables here, so I will appreciate if you don't trip.
I have more duct tape if you need it.
I have a lot.
Okay.
Yeah, so remember, the audience is included in the live stream. So.
Exactly.
So any sounds you make can and will be used. Okay, Tom.
All right, well, my name's Tom Hagan. I'm Vice President of SARA for the last conference, my fourth conference, and I'm retiring. We have a few changes in the schedule from the printed schedule in your manual, so let's take a look at it. And I'd like to introduce one of our guest speakers, Dr. Glenn Langston from National Science Foundation, right?
Yes.
And you've been working on something that's near and dear to my heart, and that's open source radio telescopes. You're working with Ellie White also, is that true? Ellie is here, there she is, back again. Well, thanks for coming out. So, let's see, I think today
That's Sunday.
oh, it's Sunday, yeah.
Blue bus.
Okay, Monday Friday, I swapped, I think, Skip and Russ at 4 and 4:45. So if you'd mark that on your schedule, please. Let's go visible.
Well, I can read that.
Let's see, I believe the rest of the day is good. And then we have tomorrow. Yeah, I had Wayne Kane down for 2 sessions in the printed manual here. And I think at 4:10 p.m. we will substitute Jay Lockman. Is Jay here? I haven't seen him or heard from him. He wanted to talk about his radio astronomy course. So anyway, we'll put Jay in at 4:10 p.m. today, or tomorrow. So in place of Wayne Kane.
Okay, where is Wayne going on the schedule?
He's already on the schedule.
Oh.
I put him down twice accidentally.
Yeah, I actually have
okay.
2 papers, Tom, so the one tomorrow at 11 can
Yeah.
be the correlation of
Okay, well,
SID data.
you can do them in whatever order you want. It doesn't
Okay.
matter, I guess.
No, it shouldn't.
So I believe that's everything. Has everybody had a chance to look at the schedule who's speaking? And are there any other questions or issues or anything else? I assume there isn't, aren't. So that was the schedule that I excuse me, wanted to discuss. I guess that was about it. Okay, Ken, I guess you take over.
Well, give me an extra 10 minutes. I'm going to start off with like a service announcement. What I want to talk about is that does everybody have a room to stay in? Does everybody get a room? Anybody who got missed? Because we had a bit of a disconnect between, we have a brand new treasurer, we have a brand new person who's also working here at Greenman, and there was a few hiccups, but we'll get through it. We'll adapt. So everybody has a room. I don't want to get too philosophical, but one of the things that I wanted to talk about is, we have a mission statement, and how many people have actually read the mission statement, and then further, get all of the aspects it's touching. I went ahead and I printed it, and this is my stuff. There we go. The reason I'm asking is because the big part that I see is we're here to make the complicated simple and then present it to students and so forth and teachers. I feel that is our mission statement. And that's why we're here. We're here to give out what we've learned and then also to absorb what others have learned and try to explain to us. So I would encourage, I was able to actually find it. It's on our website, under administration. We actually have a mission statement. And I'd appreciate, not right this second, but everybody look it over and say, is that what you're doing here in SARA? Are you trying to make one of these points or all these points possible? No. That was interesting. No. What? So we got through last night again. My apologies, but everybody's in a room now, and I believe everything's stable. Correct? Well, as stable as can be, right, Dennis?
Nobody's hollering at me. I feel pretty good right now.
Yeah, Dennis. So one of the, and then I had a homework assignment. I'd like you to look up a word. It's what I've gotten to know. And you got to be careful how you say it. But it says in the Bible, it talks about people with hoary heads, people with gray hair, people with, when you look around, what do you see? If you do see hair, it's gray typically around here. Wouldn't you
March.
But fine smelling. So that was just another point I wanted to make, because that's why we're here. I thought we had a great time last night out behind the dormitory and setting up examples, and that's what we really want to get the kids, here's the younger adults and so forth, get them out there. That's what we're here for. That's how I believe. So, anyways, any questions? All right.
Room
No
keys.
climbing.
No climbing? Oh, yes, please. That goes without saying.
Of course, I don't know about how it applies to this crowd so much, but I can kind of say.
Yeah, there's no climbing on anything unless, well, yeah, there's just no climbing. Is there going to be is the high-tech tour still,
As far as I know, yeah.
is still a go? Okay. And will there be any access to the,
So you did mention that they may be going into maintenance mode.
okay.
It's supposed to be in maintenance mode Monday, excuse me, Monday through Thursday.
Okay.
However, we've noticed it's observing still this morning, so
Right.
Sue Ann was not sure what the schedule was going to be.
But she'll let us know, so.
She will.
For those who, I'm mostly interested for those who have not yet had a chance to go up into Arizona. All right then, well, if there's no others, I will seek it.
Room keys.
I'm sorry?
Room keys.
Thank you. One of the problems we had, and I found out, is the individual here didn't realize that many of the rooms had two people in it and only put one key in the envelope. So if you are one of those people, I would, I'm not remembering his name, but it's the office where the slots are. So they normally put the envelopes, you should be able to go talk to them.
Which room?
I saw Mr. Cruz, he shaked it, he agreed. So,
Which room?
oh, which room number? Yeah.
Mine was 208.
Which room, which
Oh,
room needs
here.
another key?
Yeah,
Oh, they could use one.
two,
Yeah,
so you got two people in there? Okay. All right, yeah, go right down, when you have a chance, go down to the end of the hall, the reception area, the guy's name is Mark Barnes, and he's got the keys. All right, thank you.
Or as I like to say, a dog with a hair lip, but anyways, yes.
Is Bruce Russell here?
Bruce was.
Rich Russell? You have been checked on, and
By the
I
way, Ken.
reported that you are here safe and sound.
By the way, Ken,
Thank
it's
you.
Jeff, not
Jeff.
Mr. Cruz.
Oh. Well, that's the, what, my head it came and I said, I love to use a person's name if I even have, very good job. Okay, so without further ado,
Wow, 15 minutes ahead of schedule.
don't let it go to your head.
I'm gonna probably be done a little early too, but we don't have to worry. We'll get behind schedule as the day goes by. I'm going to talk a little bit about the SARA sections. We've had them for about 3 years, so I've been going over and promoting some awareness on them. So if you're a newcomer to SARA, it's a great place to start. If you go onto the websites of a lot of amateur organizations as well as professional organizations, you'll see that the organizations divide by different topics there, whether engineering or science. So this brings SARA into a similar organization to that. So looking at this, I do have some slides, but I wanted you to take you to our website first. We've got 6 sections, the analytical, the electronics and instrumentation, the galactic section, outreach, solar system, and stellar. And we have coordinators in for all of them. So if you're interested in learning more about the section or volunteering to do some help, you'll contact those coordinators that are listed in each of the individual sections. There's also an introduction page there as well. That has a lot of beginners information there, so if you're brand new to radio astronomy, it's good to have a look at that as well. There's also a education section. You'll find more items. And in putting together the SARA section, there was always a need sometimes to create a new guidance document or management document or a policy. So you see a lot of that under the administrative. There's a lot of good material there. And as Ken pointed out, that's where our mission statement is now, right? Okay, that's good. And it's got some historical information in there too. So check those out if you have an interest in those. The individual sections, there are some, everybody who's the coordinator does that as a volunteer position. So they're being built slowly with time. New things are being added to them every now and then. There is some similarity to the format of the sections. Every section, usually towards the bottom, has a, we'll go into one then. You usually find a link to a radio observing award program. This is through the Astronomical League. So if you want a good place to start with projects, check out the link here. There's also an outreach award provided by the Astronomical League. You'll see that under the outreach section. Yeah, this is a really great way to learn radio astronomy. I went through the program myself and picked up a lot. And now I'm just doing other projects. I'm going to talk about a group of us in SARA trying to put together a Cassiopeia A observing program. And then you'll see on some of the sections, notably the stellar, the galactic, and solar system, you'll see a data template. We put that together about a couple of years ago. It's, if you collect information on your radio observations, what are the input parameters you want to know so that it can be useful to others. Now that'll probably be updated further as we try to launch this CAS-A observing program, but we're trying to standardize the templates and what do people look for. So that's a little bit on the website of the sections. And the coordinators, you'll find right on top with their email address. So of the 6 coordinators, 4 of them are here today. So I do the analytical, Bogdan in back does the instrumentation, Dave does the galactic, and Skip does the stellar. So if you want to talk to us while you're here during the conference, feel free to do so and give us your thoughts. One more thing. I've got a short update, but what I presented yesterday for the 20-meter demo, as well as today's, is all posted on the analytical section website right here. Because within those presentations, I've got some links, so if you want to go there and look at information, just take a look over here. So I went over a little bit about this, the sections, their purpose, trying to bring together different interests within radio astronomy and get some projects going. There's a lot of things you can do as a volunteer for the sections. I mean, if you got a lot of experience, that's always useful. But if you're brand new to the organization, want to learn, the sections offer a lot of opportunities. That's how I started learning a lot about the radio astronomy. Just organizing the knowledge, seeing what's there, seeing if there's any observation manuals. If not, maybe putting together a couple myself as best as I could. As a SARA member, you're probably on the listserv, which is very, very active with a lot of nice discussions going. That listserv is archived, so all that information is saved. I actually tracked it down once. It's really a treasure for a lot of knowledge on different topics. So if you're new and you want to learn something about radio astronomy, it's possible you could get access to that, and extract the information on a particular topic, maybe put it into an observation manual, work with the section coordinator, and maybe come up with a draft manual. It doesn't have to be perfect. In fact, anything that we post, there's always a disclaimer on top that this is an amateur effort, that it's not done, it's a living document, it's going to be updated with time. There's a SARA section team that occasionally meets through email. If there's something to review, we look at that. So if there's comments on a particular posting, if we don't have time to follow up on those comments and incorporate them into the document, we'll post them at the end of the document so that a future reader can go in, look at the document, see what somebody else said about it, said what's missing, what's needed, and that's also available as a project. So there's lots of things to do in SARA if you want to get involved. And I list a few more here. Some of them I covered, but others are listed here. So these are the section coordinators. The solar system section coordinator, Whit, he couldn't make it here, but I always ask him if he's got anything that he wants to need to present to the group. So he wants to, in the near future, update the solar system section. So if you've got ideas for him, suggestions, please get in contact with him. His email will be on the section. He's looking to post some of his papers. He's one of the SARA journal editors, so very competent. He's got a lot of good papers. He's looking for data and images from other people. So if you got stuff that you think would be a fine addition to the SARA solar system section, get in contact with him. Of course, the solar system section includes the sun, it includes Jupiter observations, as well as geomagnetism. So there's a lot of stuff that is out there. The timeline on the sections, as I said, were created about 3 years ago. We've had some meetings over the last couple of years. What could we do with the SARA project? What could we observe and how do we go about it? There are some observation programs now like Radio Joe and SuperSyd, but is there something that SARA can do that's wholly SARA? So one of the suggestions last year was, why not observe CAS-A? That's a supernova over Edmond. It's the brightest object in the sky apart from the sun. It's fading with time. The fading is not constant. It's got a lot of interests. Scientists are very interested in it as a calibration source. So having good data for it is something that scientists would appreciate, and it's something that we can do. Once the target was proposed, I did some searching, and one of our keynote speakers, Dr. Dan Reichart, in 2013, he was our keynote speaker. But he published a paper with his PhD student, Trotter, last year, and actually he developed a methodology for observing CAS-A, and it's fading with time. So we're going to use that as the template for our own observation program. And he went back to the 1960s looking for data by some other astronomers. He did some data analysis to see how valid that data was. And all of his observations were done with things that are available to amateurs and us. He used the 40-foot telescope here at Green Bank, and he also used the 20-meter telescope. All his observations, at least for the 20-meter, are stored on the Skynet website, so we have that. So it's a great paper. That is his paper. The link should still work. If it doesn't, it's very easy to find on the internet. Just type in fading of CAS-A Dan Reichart, and it should pop up. He lists the number of references in that paper. All those references are excellent. It's also got a reference to his student's dissertation. Yes?
I just had a thought. The fact that he used the 40-foot and 20 meters, do you know if he's interested in having amateurs help out with this? Is
I think he would be, and I'm planning to contact him in the future about this.
Yeah.
Yesterday with the 20-meter demo we talked about, there's still a lot of pieces to pull together. We want to try to get some good observations of CAS-A, because it's not as simple as just pointing the radio telescope there. You have to remove the background, you have to remove the instrument noise, you have to follow some methodology. We have to think about where to store all this and also do some of the modeling and fitting. So at some point in the future, I do want to reach out to him. I think he would be interested because I think the whole 20-meter Skynet project is partly funded through the NSF. So, but yeah, that's one of the next steps. Yes?
The Radio Jove management team has managed to confirm that if you take the Jove phase dipoles, take the south phasing cable out and rephase it to the north for the right elevation, we can detect CAS-A simulation.
Okay.
And able to, you have to be in a quiet location, but I have measured it about 1 dB above galactic background, but it is possible to see it.
Okay, so then you can submit us data
You can
too.
see it. You can see it with a simple, with not CAS-A itself, but the simulation, and you can see it with the Jove set of dipoles.
So as we collect data from different radio telescopes and receivers, that's one of our challenges. How do we standardize that? I mentioned there's some existing templates from a couple of years ago, but we got to go beyond that. So this morning we were out 7:30 in the morning and earlier than that for SIG-A collecting some data, and we have some data from the 20 meters, but we're going to try to expand that database. So next year I'm hoping that we have some data, we have some thoughts about how to store that, and we would have tried to translate Dr. Reichardt's paper a little better into plain English where amateurs would understand it a little easier. So it moves at a slow pace because, again, we're all volunteers, but we're moving it along. And we are hoping to integrate the Radstar receiver in there too, because that is a low-cost receiver for radio astronomy, and if we can integrate that as well, I mean, that's excellent. So when people buy this receiver, they now have an observing program for that as well. So I think it's got a lot of good potential. And a little more about the CAS-A program. According to Dr. Reichardt's paper, he used the 40-foot scope. He's got data over 15 years for that. For the 20-meter scope, he's got three and a half years of data. It's in L-band and X-band, mostly L-band. All his observations are also on the internet. You don't even need a Skynet account to get into the 20-meter. You can follow the links. So in one of the other papers, PowerPoints, the one I used yesterday for the 20-meter scope demo, that's got a list of Dr. Reichardt's links to his data in the 20-meter scope database. So they should all be active. You should be able to click onto them and see that data, how it was collected. And if you've got access to the account, you can actually go in there too and look around at other items. As I mentioned, it's a primary calibration source. It's fading, it's unsteady. That's why he did some of the model and fit testing of the data, because it did appear to be unsteady. So he wanted to check if the data collected in the past was valid. And he looks at data two ways. He gets absolute values, but he also compares CAS-A with SIG-A. SIG-A is also bright, but it doesn't vary. So he's got two ways of measuring the variance. He's also touched upon in his paper another target, tau-A, which I also believe is fading. So there's some potential there for an important observing program, and I've been reaching out to other radio telescope groups to see if they have an interest in this as well, and to larger organizations, talk to a little bit to AAVSO, which are the Variable Star Astronomers, and the Astronomical League, at a preliminary level if they would be interested. Their memberships may be getting involved if they had access to radio telescopes, either through public telescopes or maybe through a simple unit like the Radster. So that will develop with time. So that's a little bit about that project. Chip, were there any questions on the, or, okay, any questions from the audience? Okay. How about that? I don't have time to. So do you want a break now, or do you want to?
So I just said, so I think it's great you have this science project, and I think that it's great you're working with Dan Reichert, because he's obviously a very capable guy. I think that's a good format to do your work as, and also, how do you see it going to, like, say, like the Raster? Do you think that that's appropriate for like high schools to do, or do you think that?
And Bogdan could probably tell you a little more about that. I believe it's possible, but maybe, can you say something about that, if it's possible?
Sure. So with respect to a teaching instrument, so the thing about the Raster that we're trying to do is to make it extremely simple to operate. We not necessarily have that success yet. It's still a complicated instrument, and it does take several steps to get the results that we're looking for. But you know, as we collaborate and we work together, we can envision sort of an application that guides the person into making the necessary observations to conduct a correct and useful measurement. And so those steps are itself a lesson plan in a way. And so because we have control over the software and we're not concerned about commercialization in the monetary sense, we're concerned about creating a tool that will be useful to astronomers, to amateur astronomers. I think we can have success in that regard.
Can you expound a little bit about what it is?
What it is that you have to do?
No, what it is, the device you're talking about.
Oh, what Raster is. Raster is a software-defined receiver. It converts, it's a wideband front end with an internal amplifier, a direct conversion stage, a local oscillator embedded, a 12-bit ADC, two of them, and then a digitizer. And then the software on the PC performs the necessary functions to interpret the in-phase and quadrature data samples that have been obtained by the receiver. The trick is to match the system's gain and match the system's performance to the observation that's necessary. So you have to couple it to an antenna, just like you have to do with any software-defined radio. But the key to it is that the entire system is designed for radio astronomy, or its intent or its operation is for radio astronomy rather than telecommunications, which all the other aspects are about. Is that helpful?
Now I'm hungry to get more on hardware.
Okay.
Corner you later.
So there have been several articles along the way for the last several years about Raster, and you can look through the journal archives and see our designs and our steps and the directions we've taken. There's a team, there's a website, and we're SARA members working on this for with SARA.
As I said, on the analytical section, there's a presentation demo I did yesterday on the 20 meter. So in there's some more information on the program. So take a look at that. These are extracts from paper. This is where the data is stored. There's also a Word document I put in there to describe the CAS-A program in plain English. That's what some of the data looks like if you go into the 20 meter site, Skynet. If you weren't here yesterday, we have a temporary account for Skynet. It's on the blackboard there. Go into SARA and then type in the password, and you'll be able to see, well, you'll be able to make the dish move. They got it back up working. We tried to move it yesterday. It looks like it was down, but this morning it seems to be moving, so it should be back up. But there's links to Dr. Reichardt's data as well as a lot of other data, and also to experiment on while you're here. There's about 3 hours in the account, so you don't want to eat it up in one giant raster scan. But you know, going in there for conceptual purposes, you can, 10, 15, 20 seconds is enough to see what it can do. Any other questions? Do we take a break now, or?
Yeah.
Hey Steve, I have a quick question. Is that document available online or anywhere?
Which one?
The one you
The
have on the screen
PowerPoint?
right now?
Yes, let me show you where that is. And all these documents have a lot of links into them. Going back to the SARA Sections site?
Yes, sir.
Give it a second, go to analytical. So this is the one for the update today. That was the one you were asking about, the CAS-A. This is a Word doc. But in there, yes, and in today's PowerPoint, there it is, that link right there. So slide 6, that's his paper right there.
Okay.
So a very good paper. I mean, gives us some great guidance on how to move forward with that. So he didn't write this as a citizen science program. His paper was about the fading of CAS-A, why that's important to scientists, and how he went about that. Any other questions?
Well, since you have some time, can you demo the 20 meter running right now?
Yes, and if you want to look outside, you should see it move. So yesterday it was stuck for some reason, and that happens occasionally, but when it's operating, it's instantaneous. It'll move, so we can do that.
We never had technical difficulties. What?
It never rains either.
Yeah, it never rains.
There are different ways to get an account on Skynet. We get a little time with Greenman on it during our conference. Your local astronomy club might have an account, or you as an individual could go on to, they call it Skynet University, but there's a free course there. There's a $60 administrative fee, so it's not exactly free, but it's a great price. You get to learn how to use the 20 meter radio telescope, and they give you some account time. So if you Google Skynet University, you'll come to the page. And they got a number of online courses. And those are all Dr. Reichert's programs. But then if you also Google Skynet UNC, University of North Carolina, you go to the actual site. So that's what I'm planning to do right now. And then how to use the radio telescope is in that demo that I had yesterday. But it's fairly easy. Oops. That's the page. You're going to log in. Those are the accounts. It's in there. Along with the radio, there's an optical account. We don't have it in this one, but if you do the Skynet course, it primarily teach you how to use the optical scopes. They're all around the world. You can do astrophotography with them. You can do photometry as well. So it's a great learning tool. Look at that. I think that was ours from yesterday, right? No, we canceled those from yesterday, but the one that says ready, that was the still ready. So something's going on with the scope. Maybe they're repairing it.
It might be out of range. There might be.
Oh, now it is. That's right. Because last night so let's add a new one then. So what you do then is add a new observation. You're going to get this globe. You'll have the meridian on it. Now the 20-meter scope does have the ability to turn in any direction. So, but let's get something close to the meridian and see what happens. So how about 3C147? That's a radio galaxy.
It's a 23 Jansky source.
Is it?
Yeah, if you go to 3C145, it's a 520 Jansky source. That's Orion A.
Is it
Not
in
far.
range? Right there it is, Orion A. Okay, that's 3C what?
3C145.
3C145, okay. So that's a nebula then, right? Molecular cloud?
It's an emission nebula,
Okay.
Orion A.
So we picked that. We're going to low resolution. I say the nuances to all these things, what low resolution, high resolution is for. And there's also different modes of tracking. One is just straight tracking of the object. The other is on-off tracking, so you're subtracting some of the background. There's also raster scans, which are very intense image-making scans. They eat up a lot of time. And then there's a DAISY, which is somewhat less intensive, but sort of gives you the feel for the raster. And let's do the neutral hydrogen. Let's put that on 1420.4, I think it is. We'll do a simple track. And we'll do 15 seconds. Now, if you're serious about taking a very good observation, you'd pay a little more attention to the input parameters. But if it's up and running, it'll work. You'll see it move outside, and you'll get a data display. All right, that is ready. And let's just refresh the screen, because then if it should automatically say radioscope is moving, something like that. probably doing some sort of maintenance on it. All right, so I'm assuming, but so it looks like they're still maintaining it today. They probably came back Monday morning and they're trying to fix what was wrong with it. We can go in and though look at other observations to give you a feel for what it looks like. So let's go into, say this one. So if you want to look at a past observation, you can click onto one of them. You can go to where the observation is stored. It's got some display information here. If you want to look at the raw data continuum or spectrum, that's what it looks like. So we have all that data. Now, just because an observation is made and stored on, all observations are stored, doesn't mean it was a good observation. A lot of times there's students there, they're learning on the system, they're not always sure what to input, so you've got bad and good observations together. If you want a log to see what, so this account, scrolling down, is just only showing what was done in the SARA account. If you want to see the whole universe of the 20-meter observations going back, this is all 2018. All the way on top, you'll see the 2013 to 17 as well as you can go into. So if you have an interest in seeing what a, I tapped by accident. If you want to see what SIG-A looks like, here's a DAISY scan. Yeah. Did someone have a question? Oh. So a DAISY scan of SIG-A, the image it provides. I took some back in August of the August eclipse that was in the area. So as the moon progressively covered the sun, you could see that the power generated from some rock. CAS-A, let's see what that looks like. This another DAISY scan. There are some, I'll show you what a Pulsar Mode is. That's a little different. Let's see if we can, what was the?
Control F.
Control F. Okay. So the Pulsar Mode you get with the low resolution option, and then check the box that says Pulsar. So if you go to Pulsar Mode and click on it, you'll get an output that looks like that. And all these observations, well, if you know the observation number, you don't need to get into the account. You can just link directly on the internet to the observation. So a little different information there. If you want to, there's a lot. In my PowerPoints, I give sources of documentation for how to use the scope. There are some manuals. They're not always very good. There are some instructions on how to calibrate. Let me tap into it. So here it is, 20-meter info. They've got a lot of documents published here. Somewhere in here is the manual, 20-meter documents and memos. Let's see what's there. So it's quite a large site. There's a lot of good stuff here. And there are others trying to do the same thing. Princeton University has an 18-meter dish. They're trying to get it up and running for amateur and public use. Operates a little bit differently though.
It's not the old tire station they talk about up there in Wall Township?
Yes, that's it. Was the old Army base, and now a museum has it, Info 8 or something like that. Yeah. And they got an agreement with Princeton on using that. And he's trying to get it up and running, and he uses a Python code to gather information. So we were in contact with him on maybe how to collaborate, how to iron out some of the kinks that we want to do for an observation program. So yeah, if you have radioscopes at home or have access to data, and you want to send us some observation with CAS1, that would be CAS8, that would be very helpful to us as we try to plan a database or data storage option for it. Any other questions on that?
Who's actually responsible? Do you know who's responsible for maintaining the 20 meter?
I think, I'm going to guess it's Greenman. Because although Dr. Reichard oversees the 20-meter Skynet program, I don't think he oversees the actual.
I'm just wondering if there's a clear understanding of where the software ends and the hardware.
Yeah, I'm not sure, but that's my guess because the radioscope is on the property here, and they would have the technical capability here to work on something out. So the account is, they've got a little money in for our participants to go in and experiment with some observations. It usually lasts 2, 3, 4 weeks in there, as long as nobody's eating up the money of what giant rats they're scanning. If you're doing 10, 15 seconds to explore, you'll be able to do some observations. We did have, from last year, we had about 5 minutes left over, so actually the funding lasted right up until this year when we got a new boost.
If you pull up my account, it'll show the balance currently.
Well, this is the
I understand.
SARA.
If you,
oh, yes. You mean the account feature?
for SARA, yeah.
Yes. Yes, so it'll tell you if you have an observation in there how many seconds it's going to cost you. But you want to look into the account and see what's left. We just got that boost yesterday. Sue Ann was in here. We asked her, can we have a little more funding for the demo and for the participants to go into the scope and look at it. So yeah, we've got, well, that's in seconds. So do the math and it'll come out with 2-3 hours, something like that.
Question?
But yes.
So when the balance, 2 hours, I think, will go. There will be no other kind of access for SARA members, right?
Yeah, so I'm going to bring that up in the board meeting, maybe. How do we go about getting something a little more permanent?
Yeah.
If not to maybe fund that, maybe to talk to Dr. Reichard or others.
Skynet will be interested in some
yes.
sort of relationship with. Yeah.
But I think we have to be a little more coherent on what we're going to propose that we do with this But that's something to explore. I like that. And it doesn't cost too much. I think the time on here is not that great.
Do you have a figure? How much?
I don't have an exact figure, but if I had a guess, I would say $50, $100 an hour. In optical astronomy, you can do a lot with 1 hour. You don't need a lot of time for astrophotography. In radio, you probably need more. You probably need sometimes that if you're doing some good accurate measurements. But if you're just looking for concepts of what the observation looks like, you're still going to get a hydrogen-shaped curve in just a few seconds. You'll get the same thing, same shape after a longer time. The difference is accuracy. The lower time observations are going to have more noise and other stuff in them that's going to skew the observation field. So those are, yes, things that we like to look into. Other questions, either on section or the proposed observation program? Yeah, the sections are a great way to get involved, so I would encourage you to contact the coordinators of those sections if you have a particular interest and explore with them what could you do. That's part of the learning. Radio astronomy is not like optical. There's a lot of literature out there that tells you how to go out and observe. So part of radio astronomy is discovering how to do that yourself as well. So if that's what you're doing, you've done that in the past, so why not share that knowledge and put it into an observing protocol that we can post. And again, it doesn't have to be perfect. We understand that it's something that's going to be developed with time. All right.
Thank you, Steve.
I'd like to real quick grab 5 minutes for Jim Brown. He wanted to make a comment about Radio Joe before we go on break. So, Jim.
This is all kind of last minute, so sorry if I'm going to eat up some of your time. Following up on what you just talked about, during our conference, a 3-day conference down in Gainesville, Florida, the Jehovah management team, there's some stuff I want to talk to you about the SARA grant program, but following what he said, and I'm not going to get into detail, you can look this up yourself. But sorry, I ripped my Rotator Cuff. If you get onto the web and you look up I can't even spell otterplot.org. That is a data manipulation program that was developed by NASA, JPL, and some soft money from other people. It is probably one of the most powerful data manipulation tools you can find. It's written in JavaScript. It will take fixed data. You can play with it all day long. You can graph. You can break it down. I mean, it's absolutely amazing. They just accommodated us. It will now take our SkyPipe data. It will also take Jim Sky's spectrograph data. I'm not going to talk more about it, but go online and look at it. It is an amazing piece of software. It's got like 1.5 million lines of code in it. And they've been developing this for about 6 years. So it is incredible. All right, what I want to talk about, can you bring the SARA website up for me? And get to the grant section, pull up specifically the grant application. One of the things that the Joe management team realized is we're not getting any feedback from the programs. The grant that we give away, Radio Joe kits, we also give Super Seed kits. We're not getting any feedback from the people who are grant recipients. We sent out, we have already to date, since the Joe program started, about 2,200 kits have been sold or distributed in one way or the other. We just put out a survey asking for some feedback, and out of the several hundred requests we put out, we got that 30. So we have absolutely no way of knowing what's going on. Now, it occurred to me that in the SARA, you have the grant application specifically pulled up. I think it's a PDF file. In the grant application, It specifically says, do you have a mentor? And the next thing it asks is, will you be willing to present a paper to SARA or make a presentation during a conference? And invariably, they always say yes, 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 because they're just trying to get their equipment. Well, what happens is they get it and they go away. We never hear from them. Are these things being built? Are they being used? Are they collecting data? We just don't know. What I'm going to propose to the board tonight is that we change the application. You must have a mentor. List your mentor. So I'm going to ask the members of SARA, if you have any objection to somebody contacting you about the Radio Joe program, let me know, or let Tom Crowley or myself know, and then we won't, with the exception of. But we need somebody to literally act as a mentor and have somewhere in there, you must contact your mentor within so many days of receipt of this equipment. You must report to him so many times during the project. He must be able to come and look at your data, whether it's a science fair, whether it's a school project, whatever, or we will make arrangements to come see you. That's the only way we're going to get feedback and know that these things are actually being used. We have no idea. You put a grant program out, they get a Joe kit. How do we know they're not just selling it on eBay? We don't know what they're doing with it. So we need to have some sort of feedback. And the way the grant application reads, here, you can have it. And then there's no follow-up. There's no way for us to follow up. So we're going to have to almost make it a mandatory follow-up.
I agree with you, it sounds wonderful, however, knowing human nature, they'll still ignore you. But if, this probably isn't feasible.
We have to try.
But if you make them give you a deposit of $100, refundable upon the first report they get back to them, then you may actually...
Well, I'm going to bring this up to the board during the board meeting and see if there's some way around this. But the problem is that we're giving out all these kits and we have absolutely no way of knowing what's going on with them. We get a gazillion requests from India. What are they doing in India? We don't ever see any data posted on the Jove archive. We never get, we just don't know what's going on with this stuff. So,
what if you had them go through the mentor to get it instead of getting it ordered directly? So
well, that's what I want to talk to the board tonight, see if we can't brainstorm and come up with something. If somebody has an idea, catch me up in the Drake Lounge, because I don't want to eat up your time here. It was just something last minute because we did have this management team and we were banging our heads off the wall trying to figure out a way of, at least at this end, when we're granting the stuff and giving it away, we need to have some feedback to know that it's being used in the way it's intended to be used. So I'm just throwing that out on the floor. If you think of anything, catch me up in the Drake Lounge. Sorry for eating up some time. This was all last minute sort of thing. Again, autoplot.org. You will have a field day. There is a learning curve with that, but there's documentation there to do it. Yeah, thank you. Okay, break time.
Just outside of Washington.
Senior in school, trying to follow
They do. Elizabeth Warren, are you in charge? Well, I'm on the analytics section. My email address is on the end. Go to the SARA Sections. Well, I usually. Yeah. Let me. This was the first picture they had. So that's what everybody saw. In fact, the funny thing was it was in the national requirement. Given the size of the copy of that one.
Anybody want to come that chair?
You're definitely
Where can I get my printers?
Which one is
Stephen, one word, Chikas, Chikas, @gmail.com.
Okay. And you sent your, there you go.
Thank you.
I do some,
But Amelia's gonna do the whole thing.
it's that and the other, but I'm changing the
That's my
do a lot of public stuff.
Okay, so this is what the county did?
Yeah, I represent the county.
Okay.
But again, I came here for this,
Yes, that's a great one.
So this is a national organization. They have like, okay, yeah, I've heard. So this is, so the members get together and have talks about it.
yeah, I mean, I'm not doing it through the course of, but, you know, not wasting energy and keeping the skies dark, or something that, hey, heck, let's do it.
Check out of your motel.
Yeah.
We have rooms.
Okay, good.
All right.
My place was not 25 miles away, it was 45 miles away.
We have
And,
rooms.
long, dark drive to the
Okay.
mountains last night. Thank you, I'll be right there.
I haven't seen me yet.
Okay.
Tonight,
That's right. Thank
Oh, I have the listserv. Are you on the listserv?
I've never heard of this.
Yeah.
Oh, you want to go on that?
It was
Every day there's tons of emails. They get the very complicated, easy and complicated.
So just look up this survey.
No, there's a way. In fact, when I got on, I asked, how do I get on? And somebody gave me a link. I started getting tons of really informative.
Yeah, I'm a fellow.
Where are you located?
I used to run a student group.
Okay. And
You guys got
which group?
airplanes?
I'm not sure, my dad, community.
We got ourselves here in the Navy group, so we built ourselves a little mini carrier. And they got, normally the students groups, we got paper airplane contests. We're gonna land on the carrier, so we had to have folks and,
Okay.
So you want to get an account.
Yeah, absolutely.
Because otherwise, they're going to hear it and say, oh, we can't get on.
Yeah.
So,
They probably won't hear it. They just want to get an instruction to regular money, and then it's also, what kind of thing you can do. It's not
yes. I used to belong to know that.
Yeah, okay, right.
They have an account. That's how I learned about it.
All right.
There's probably a link somewhere on the SARA website.
Okay, thank you.
I've been trying to get out there for a very long time.
I made that there just like.
Yeah, it's very simple, I just don't know how, but, oh, they gave you a link.
Go for it.
Yeah, well, if you're missing out on it, yeah, you want to go into that. That is like a, now this is not the archive I talked about, this is daily people going on. And then you could jump in and ask a question, and they respond, you get good feedback. It's technical stuff, they're really smart
I
people.
wondered last year if you had a forum, but I never heard anybody talk about it. So
Or maybe listserv for.
You know, eastern, southern, northern. Yeah. They all talk different languages.
And somebody just raised aliens.
AS.
I put it in my umbrella.
Well, if you call me and I'm not home, leave a message. Because I get too many calls where they don't leave a message.
I don't call me back there.
So 703-262-0928.
It's been years, I've tried to get
Yeah, a year.
And I did it for the last one, actually the last one came up with the weather. But that's when it gets hard to see how to set up the too. That's good campaign. be a good place to set up a demonstration. It's about halfway between, DC and Front Royal.
Yeah, they gave, yeah.
It's not far off of 66 though, it's, it's a good location. It's not bad out there except for things in the street, but yeah, that might be a good place too.
So you're not necessarily, so if you don't have access to the 20 meter, well,
I can set up the way you have.
well, that's gonna disappear probably.
That's all, I'll get over here when I do it.
That's like a 2-3 hours they gave us. I haven't, I'm not getting their no back anymore, but they have the account, so I didn't give you that, I was gonna go with there. And you might suggest to, that, or how many people, because so far as education, they might get some, I think it's like the blue shirt, as I said, $50.
With a blue shirt.
For optical, that is, yeah, for optical, that is plenty. For radio, most people don't know what they're seeing when they look at
That's why you're saying it's amazing.
radio.
It's amazing. It's just crappy.
They get frustrated because it's not as easy as optical. But yeah, to have a real telescope,
you have to try this.
and it usually does work, it's just not working today. I think that's a great school. And all they have to do to set it up is to talk to Dan. He's on that webpage, Skynet, UNC, University of North Carolina. So he's a keynote speaker. He's out there. Where the alternate is, have the students take the classes.
One area like ours, that's actually
I forgot the last part, I'm not going to display the part.
Anyway, but
She'll make up for it.
Yeah, I already studied like the paper, so I'm got it down.
The interesting thing is,
yeah, I see a lot of people. I'm so glad you're in the area. I'm going to get a list of who's in this area. I want everybody.
quite frankly, be careful, please.
sit down.
No, she'll probably, it's not mine, that's fine.
I'm sorry about taking up all this time.
I'm thinking,
And then you bring up information too. Well, I'm sure that I was able to take I got up early and the observations. Yeah, so I like it. And I say that it's 45 miles from here, so I'm glad to be here at all at this point.
so this is more, you want this more focused with radio stuff.
The other attitude is, anything, see, I'm for my department, I can do that unless it was near nearby.
So, yeah, I think.
I got the radio clubs around the country too. There's another place.
So we're constantly tracking projects, that's what you're doing. And I think we lack everybody wants to.
There's no, you don't have to set anything up. There's no shortage of infrastructure already in many places.
Well, as my pastor says, occasionally, it kind of gets to,
So, there's two.
Actually, so I
I'm on board with whatever happens.
well, I just thought it's kind of just a variety, because quite honestly, what I don't want to limit people to terms. I want to say max 2 years, you got to sit out for 2 years, then you can come back to it, or whatever. But there's got to be, there's shit people.
That's the first one?
That's a lot.
Okay, so are you
And then you order from class 1 to
Okay, well, I'll start uploading more like about somewhere between 10:25 and 10:30, so it's really important. We'll make it with all of you.
Yeah, that one,
Awesome. Thank you so
the only problem is the software is developed. It's not,
So it's not something
you can't do anything. I tried to do something, but I actually started to use that software this morning. With the Siemens. And I got two last year we did. I had to.
No, but,
That is one of the nominations for president.
I have no idea. I don't know how it keeps getting on the ballot. He just became a board of director and then there's the last name.
Okay.
Yeah, I didn't know he was on the ballot.
You have a good voice.
I just don't know.
Okay. Some people do. I probably do also.
Now,
if you're good, well,
Jim Sky now, here's the thing.
Yeah, absolutely. You know, we've got some astronomy classes. Now, there may be somebody who does read astronomy, I just don't know that.
That's Amos.
Earth Day time, well, that would be a good time. That's a good time to catch.
Or you know, Dad goes and then it's going
Then they'd have an advance notice of this time.
oh my.
Right?
Get people in the phone.
I was like, oh no. I was like, that ain't happening.
Yeah, I've been part of one of that. Oh yeah, I've Mr. Johnson and friends, absolutely. I'm a solar astronomist, so yes, I have a telescope, and yes, I'm big solar. Okay. And actually, you know, like we have a called Rocky Science, and that's actually community colleges I'm talking about, and they have a lot of solar science and that's something about that, or they did the eclipse, or you know, whatever.
Oh, I saw it.
Yeah, just a little video. Actually, the Air and Space Museum downtown, I started doing some of the programs. They also use daytime astronomy. I haven't seen the radio.
How do you feel leaving that?
Oh, I saw that mistake. I thought, this is
If you freaking figure out a way
have so many creatures in our area, just many dish TV. Like the time we used to turn our telescopes? It seems like
they actually decided to say
What is that? All right.
In another life, I used to work for Radio Shack. I'm familiar with some of these
We interrupt this message for a commercial. Hi, Jeff Kruth here, and I just wanted to point out a couple things.
$10 each.
Yeah, there you go. My boss, Ben Malfors, used to work here, and he wrote this book on the history of NRAO and big science and radio telescopes. That's a pretty good one, so he lets me bring some of his books out and sell them when I come to one of these. He gets the money, I get the glory. But pretty interesting pictures. You know, the picture of the 300-footer that fell down, that's his picture. The one that's in the proceedings this time. Ben worked here then. The day before it fell down, he took a picture of it. The day it fell down, his was the first picture went out on the wire service. So all that, a lot of great pictures there, a lot of good stuff. If you're interested in this stuff, I got them back there anyway. And for those of you who follow the reflector, we were talking about scalar feed horns and how they work and all the things. And this is one of the ones that I built myself in my shop, actually in my garage. So I brought it to show people, and I can describe what goes on here. This is a dual circularly polarized 2.2 gigahertz feed, but it can scale to 1.4 pretty easily. And you know, the good old scalar ring on there and the method by which it works and the Kapton window and all that. So if anybody wants to talk about this, just grab me sometime and we'll chat about how to build these things.
First, we need your garage.
There you are. And I've got some good friends.
Okay, Wayne, looks like you're ready to go.
Okay.
Next speaker is Dr. Wayne McCain, Athens State University.
And Colin, who did a lot of the research initially, and he's going to set it out and watch. He's actually taking his first speech class at Calhoun Community College right now, so he's declared he's not quite ready. Could we dim the overheads a little bit back there? Skip, do you know how to do that? I always like to not have so much glare in my eyes when I'm doing a presentation there. Okay, well, most of you have already seen presentations on our proposal for a radio astronomy CubeSat. We first presented it at SARA Western Conference in 2017. We presented it here last year at our annual conference. We've since made several other presentations, Alabama Academy of Science, several different organizations since then. And what I wanted to do today is it's going to be kind of a short presentation because I'm not going to go into the great detail that I normally do, although that information is in the paper and there's color handouts on the table outside of the PowerPoints and the paper. But basically, you all know very, very well that there's a whole lot of radio science out in the universe that can't be assessed using optical astronomy. So that's basically why we're here. And a couple of years ago, really, we started talking about the possibility of doing a CubeSat project. And we wanted to develop a science mission around that. And basically what we've come up with is to do a CubeSat that would receive low frequency and very low frequency signals above the Earth's atmosphere, those that are typically blocked by our ionosphere. And there's lots of science out there ranging from SID type information from the sun to supernova, pulsars, black holes, AGNs, just a lot of things that can be done in that part of the spectrum. And as it shows over here, the problem with Earth observations is that during the day, anything below about 10 megahertz, and I think at night it's around 5 megahertz, totally blocked. The Earth's atmosphere just makes that opaque. So even the VLA, can't do much science in those areas, or at least it's restricted. So very briefly, what's a CubeSat? Just talking to Jeff back there, things are changing so rapidly in small satellites it's hard to keep up. But a CubeSat in a 1 unit size, 4 by 4 by 4 inches, pretty small, weighs about 3 pounds, okay? It's got to be self-contained, totally autonomous from the launch vehicle. And the typical launch is that the CubeSat rides piggyback on an existing payload. They're normally deployed after the mission payload is deployed. A lot of STEM and student involvement, everything from design to building, testing, collecting the data, analyzing the data. This is a 1 unit CubeSat size right there. So, also CubeSats are launched from the space station. They can go up on a cargo vehicle. There's a special P-pod thing that kind of Gatling guns them out into space after a certain time. So anyways, lots of ways to do it. So we have changed the objectives of our mission since last year and made the primary objective science education for kids. Science, technology, engineering, and math, K through 12 and higher, everything, mission planning, ground station operations, data reduction, correlation, whatever. So the main mission now would be STEM. And so the science part of the mission would go to secondary objective, basically, where we would actually develop a receiver of some kind that would receive these signals. We've looked at possibly a variant of raster or some of the other smaller things. And what's shown here is a simplified diagram. We've worked with AMSAT some, Jerry Buxton, their VP of Engineering, kind of in talks with them constantly. And so the science experiment that we would develop would potentially interface with something similar to the Fox series of satellites in a 1-unit size, something like what Vanderbilt and others are doing. Vandy has 2 satellites in orbit now, I believe, and we've talked with them. This is kind of a picture of a cartoon of what it might look like. All these interesting things coming from the universe at LF and VLF frequencies can't get in due to the upper atmosphere, but a CubeSat can receive these signals and retransmit them to an Earth ground station at VHF frequencies, like 2 meters, like we have a 2-meter download. Question?
So what's to prevent you from having everything overloaded by terrestrial signals?
Very good question.
Well, the ionosphere will help
problems.
you in that regard as well.
Well, don't be so sure.
Yeah, and this has come up. There's a lot of Earth-based interference that we might have to deal with. So we'd love to hear your thoughts. As I said, we're basically 1 year later, we're still scratching our heads in the planning session. So if you thought herding cats was tough, just bring this subject up. And people are very interested, and then they walk away and wait for it to happen, right? Also, since then, we have gotten another group of students involved. This is a picture of the Athens State AIAA officers. We have a student branch of the American Institute of Aeronautics and Astronautics, AIAA, world-renowned aerospace professional organization. We have a huge section in Huntsville, the greater Huntsville area section. And so we have this student group. These are just the officers. There's 15 or 20 kids in this group that varies from term to term. They have volunteered to take on the project management of the CubeSat project and whatever other. A lot of these people, notice most, except for these 2 young ladies here, most of the people in the thing are adults that have come back to finish a degree, so they're already working at the Army or Marshall, NASA, someplace like that. So they occasionally bring a lot of technical savvy too. So these people have agreed to do that part of the project, and we're basically still trying to put a mission plan together. Here are if you recall, the last time I showed this chart to you, there were lots more organizations on here. We've kind of weeded it out to the people who are really going to participate, and this is what the list looks like today. Some support, of course, from SARA, the AIAA student branch at Athens, and these organizations, Vanderbilt has agreed. As a matter of fact, we've already signed an agreement with Vandy, and for a year now we've been waiting for their legal department to say it's okay. I don't know what's up with that. Florida Tech has agreed definitely to work with us. David Fields, who couldn't make it this time, he's working with a group in Knoxville who already has a launch slot for a satellite, so he's helping us. Mel Blank at UNA, Alabama Academy of Science. I happen to be the current STEM education section chair for the Alabama Academy of Science, so I have a little bit of in there. They've agreed. AMSAT, about a year ago, offered us the possibility of using spare hardware. The only thing they didn't have in the drawer was a qualified set of batteries, and we think that might be overcome.
Those aren't bad.
Yeah, and then Spark Academy, my daughter Amelia here is going to present a paper tomorrow. She has been attending a STEM school in Athens, and they have a NASA certified technology teacher, Jennifer Kennedy, who's just really outstanding. So they're going to help. So we do have people that are committed to help do it. And so here's where we're going to go with this. We had an opportunity, obviously, last November to submit a proposal to NASA to try to get a launch slot. After beginning the review of several proposals that had been submitted and won in the past, we decided, hey, you know, we're not ready. The biggest thing that concerned me was the funding. In the proposal, you have to outline in advance the funding necessary for the program. And so I thought, wow, you know, it's going to be tough to get that kind of commitment. As it turns out, reading the proposals that have won, the funding list doesn't have to be all that concrete. Like, they've had letters in there from XYZ that says, yeah, we're going to participate, we're going to provide funding in support of this program. And, you know, that's about it. So we can do that. We have a lot of people who've agreed to do it. So we are planning to submit a proposal this November and try to get a launch slot. And it's kind of like a chicken and an egg problem, because until you have a slot allotted, you really can't get a whole lot of enthusiasm in support for people to help you work on the project. So we think after we...
Let me tell you a comment on that.
Okay, sir.
And if you build your satellite, even though you don't have a launch slot, and you let the people know that you have one sitting and waiting, they get a lot of guys who never show up for launch because they fail, shake, and bake. And if you've got one that's qualified, ready to go, they'll grab you and set you on, because they don't want to send up a mission with an empty slot in it. So you could be the standby guy. So that, if you go back with that kind of information, and hey, if we build it and just put it here, they may come and say, we got a hole for you to go.
That's good. Yeah, I told Jeff here a little bit ago, he's my new best friend. Just met him, but wow, okay. Yeah. So basically, in summary, this is what we're trying to do. It just seems to me that this is a project made in the heavens for SARA. Who in the world would be more enthusiastic to have a radio astronomy CubeSat other than us? I mean, I can't imagine anybody that would be more enthusiastic about that. So we're going to do it with the primary objective of STEM involvement. And I'm very supportive of anything STEM, even considered homeschooling. Amelia here a couple of years ago, until I finally came to my senses, and she came to her senses too. So I'm really for that. So we're going to try to work out the details of the mission. All of you who are working on SDRs and all kinds of antenna. David Fields, who couldn't be here today, has already done some antenna development work in Knoxville. We're planning, and SARA approved last year, a small budget to launch some of the hardware on a high altitude balloon. We haven't progressed on that yet, but we still plan on trying to do that and making it, if possible, part of the proposal.
Make sure you have a tracking beacon. They're hard to get back. We've done those too.
I can imagine so. And so anyway, that's definitely on the books. So the basic next step is to finalize our mission planning, get in a position to write and submit the proposal to NASA in November, and pretty much go from there. If we don't get an approval for a slot, like Jeff says, maybe we could go forward and have it ready to go, or something near that, so that we could be a standby. But that's where we're headed. We still think it's a viable project to pursue. SARA is natural to be involved in it, although if you notice, we're not saying that it's a SARA-only project. I mean, SARA is going to be one of several organizations involved, but it seemed like a natural. Okay, questions? Jeff, first?
Well, I don't know how detailed you want to get into this, but the first question I'd ask you is, what do you expect your data rate to be from your sensor? Because getting that data down to the ground is hard. And when I mentioned that Global Star modem, that's a really useful way you can get 10 kilobits per second out of it. If you're using a ground station with a LEO-based CubeSat, you're gonna get maybe 4 passes a day with maybe maximum 15 minutes a pass. And so you don't get a lot of time to do the handshaking and get all your data down. With a continuously operating sensor like you're proposing, you're gonna generate a vast amount of data. So I just wondered if that was something you'd consider. By the way, the batteries, you know where you get those? You go out and you buy a drill and you take it apart, you take the 18650 lithium cells out, they're space qualified. They're already accepted by NASA, you can use those, that's what we got ours. You buy 2 or 3 battery packs, you take them apart, you cycle them through, pick the best batteries out of it, and now you got your battery pack.
The Rockwell drill pack.
The Rockwell drill pack's the best one.
Okay.
Been
Good
there, done that.
information. Yeah, that's my new best friend back there. Okay.
How much money are you looking for
Well,
when you said you needed money?
yes, we don't know how much money we need because we don't have the whole thing planned. I know that Vandy spent $200,000 on theirs, and they had a government contract that they were able to get support from because of their mission. Vanderbilt has their objectives have to do with assessing the radiation effects on semiconductors in space.
Very, 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 very important topic.
It is, so there's a lot of government support already there, but...
Is that a high altitude, Leo?
Well, I think the latest one they put up is higher than the first, but I think we're talking 400, 600 kilometers.
Radiation effects within Van Allen belts aren't that bad for semiconductor stuff, and that's why you're able to get along with things. I'd recommend for your receiver system, one of these little sticks, a Raspberry Pi, and a ferrite loop with an up converter, and then that would be small because deployment of antennas off CubeSats is very difficult.
Yes.
And they don't work well on one use because there's not enough ground poise.
Yeah. And by the way, Jeff also suggested that we might want to consider a 2U or something. I'm not sure if that fits what we want to do, but
well,
absolutely.
They might take you more seriously. Most of the one and dones, the people who do one and it fails and they don't do it anymore, they're 1Us.
Right.
A 2U shows a real commitment. And of course, a little more money.
Yes, ma'am.
Have you explored the possibility of using one of these crowdfunding platforms? Since you're doing it for educational purposes, there are a lot of people out there who might love to see a pilot like this go forward. Yeah.
Absolutely. It has come up. We have not established anything yet, but absolutely.
Yeah, please do.
That's a good way to go.
Have you been talking to the Stanford VLF group at all?
No, sir. I'd like to.
I recall that they developed a super low power VLF receiver that was space rated. And,
Oh, big money then. That's going to be a big money thing. If it's space qualified, then, you know, this is one of the areas.
Well, I mean, they may have a couple of these left over from the original project. I don't know.
Yeah.
Well, I think I like everything Jeff said about the Raspberry Pi and the stick and the ferrite core antenna. Yes, ma'am.
So I was just wondering, so you mentioned all these different universities that were partners in your STEM Stack program, and I was just wondering, what are these universities' roles? How do they contribute to the project in most cases?
Let me go back and I'll tell you a little bit. And those roles haven't been totally defined yet. The agreement we signed with Vandy pretty much was a technical consulting sort of agreement, that they are going to provide engineering support, analytical support. This is out of their electronics center. They have a huge commitment for electronics in space and all that. A lot of government contracting. So they're planning to do consulting. Florida Tech, Dr. Don Platt is the director of their Space Systems Engineering Master's Degree program. He has agreed to provide support in the project management and planning area as well as technical. He runs a small aerospace company down in the Cape Canaveral area. Rome State, David Fields is connected with them, and they're basically doing the balloon concept equipment demo with high altitude balloons. University of North Alabama, they're more data they're basically an optical astronomy group over there, but they very desperately want to get involved in radio astronomy. So I think they would take out the garbage if we left them. So, really nice folks. Alabama Academy of Science, we hope to get some small funding from them. And also, there's a wide variety of people in our state of Alabama already working CubeSats. University of South Alabama has a program underway. University of Alabama Tuscaloosa is working on the program.
There's a small place called Auburn that's working too.
Auburn, my alma mater. Absolutely. Yes, sir, question? No, you just worry a good deal. And, UAH, they're in Huntsville, I'm sure. You're probably doing some stuff. They're a space grant university, and we haven't worked any with them yet, but, they are sort of all, they're like a black hole. Once you start working with UAH, you just sort of get sucked in.
So I'll give you a little tip about somebody in Huntsville. There's a company called Radiance, and we teamed with them on the Army's return to space. And we built TechSat-1 with Radiance and some other folks for the U.S. Army down in Huntsville. And they are always been interested in CubeSat.
Really?
So you go over there and you say, you got anything laying around? And you want to give us some money?
Okay. Yeah. Did I mention he's my new best friend?
Yeah.
AMSAT, Jerry Buxton, VP of Engineering, they're doing the Fox series of satellites. They have moved on pretty much from 1U size satellites now. They're working 2, 3Us, I guess, and
6Us.
Yeah, big stuff. So Jerry said, well, we got a lot of stuff left over here. Maybe you could use some of that hardware. And but they're so busy. And this is the thing with people who are doing CubeSats. It's a lean and mean type of organization wherever you go. They're so overwhelmed with what they're doing that I'm finding out that it's hard to get on their agenda for help. But they've agreed to sign an MOU with us and work with us. And the Spark Academy, this is K through 3 right now. And they're basically mission planning, and they want to have a ground station. They want to set up a ground station. But Jeff just mentioned a cool idea that might even be better, and that is not to need a ground station at all. So I like that. But that's where we are. Basically, I wanted to come and say we're still scrambling around trying to do the CubeSat mission. We haven't given up, but we basically kind of been overwhelmed. But, yes, sir.
I want to re-emphasize the first question you've got. The data rate downlink. If you haven't figured that out by now, you better stop and go back to that point. And in particular, you're not going to put much data down in 2 meters and get an FCC license.
Yes.
Well, that's right. You're restricted by the bandwidth. And also, they've really, we started off doing all amateur-based satellites, 2 meter, and then we went to 432 exclusively, and they're very resistant to that. It's very difficult to get the ARRL and the FCC behind it for satellites. Now, AMSAT has, of course, a preferred position in this.
Right.
And they're trying to protect their spectrum. They don't like the fact that all these universities are populating the LEO orbits with all these ham-band thingies.
Amen.
And so that's pretty tough. That's why I mentioned that Global Star system, and it's relatively cheap. And it puts the data straight out to the internet, so any of your STEM schools can go right in and log in and see the data, and now you have global coverage. So
anybody knows CPR, I think I might swoon up here any minute listening to Jeff.
You get the global coverage aspect, and you get the 24/7 coverage with the downlink, and you don't have to maintain any operators at a ground station or deal with wind blowing your antenna over or anything like that.
Yeah, what we're trying to do is 5 or 10-year-old technology. I mean, we're trying to get into something new with old stuff, so I'm liking what Jeff is proposing. A lot.
We would be willing, Moorhead State would be willing to sign a technical agreement with you to offer some support if you're having trouble, because we've got our lawyers in check.
I just might want to come and see that, you know, from a distance.
There's a standing invitation, anybody in the room who wants to come to Moorhead State and see our Space Science Center and our Star Theater and our 21-meter dish antenna system and all, they're welcome to come.
We're coming. We'll just work out the schedule. Any other questions? Oh, yeah.
Well, I still didn't understand the scientific aspect of this project. What do you envision the satellite will do? Because as someone said, once you're in orbit 300-400 kilometers up, you are at the mercy of those megawatt transmitters in
some of which do leak first.
Not necessarily, because now you're above the ionosphere. Where he wants to do his work, the ionosphere is relatively opaque.
Yeah.
And the sources are going to be much stronger out there. Probably consider your 1 over r squared.
Yeah.
When you're up at 400 clicks, that 1 over r squared starts to come into play.
I was thinking of what his upper frequency limit is. And the fact that...
Well, you know, once you get above the ionospheric window, I mean, then other people are doing it better from the ground, because they have more resources. So what you're trying to do is...
research topic.
What you're trying to do is you're trying to look at BLF and HF emanations that are below the MUF. And so that's perfect for that. Grote Reaver would have loved to have had a 2.5 megahertz receiver in orbit, because that's where he was looking at his electron density stuff up there.
Yeah, and you know, that's part of the process where we are right now. Exactly what is the science mission? How do we define that? What data are we going to collect and send down at what rate? In what form, you know?
One of your best approaches might be to talk about space weather. And not so much the radio astronomy aspect, which may be a spin-off or a small portion of what you're able to do, but actually observing the sun. Because they've had many, many satellites in orbit that did VLF observations of the sun, and NASA has stopped funding the observation of those. So many people at universities have picked a few of those up, but there really is a hole there now for these types of observations. Of course, some of them were out at L1 point, or, you know, out of the ground points, but you know, you could still do useful work there and maybe pave some way.
Yeah, let's talk about that. Yes, sir.
Is there a CubeSat section on the website, SARA website?
Not yet.
That might be a good place to...
Absolutely, absolutely. Now,
solicit ideas.
The paper that Amelia is going to give tomorrow afternoon kind of approaches that a little bit, because what we're talking about there is trying to correlate, supersede, inspire Earth-based VLF observations with what we might get from a CubeSat. Do those two relate at all? What are we seeing? Common events, that kind of thing. So absolutely. So maybe we need a small mini conference or something at Morehouse.
Did you cover CubeSats last year in your paper?
Pardon me?
I recall. Did you cover the CubeSats pretty well last year in your paper?
I thought I did, yes, sir.
Last year's proceedings.
Yeah, oh yeah. And like I said, the full paper is in this year pretty much, but just kind of wanted to give you an update, let you know that we're still moving, still a pulse there, we're working the problem, and one way or the other, we are going to submit a proposal in November. So, any other questions? Thank you for your interest, by the way. Yes,
just a question about, do you have a breadboard prototype of any kind now that you sort of can test or?
Yes, Dr. Fields, and I don't know if Bogon knows what he's been doing either, but Dr. Fields has been working that issue now for like a year and a half. He wasn't able to come today or this conference, but yes, he's already been doing antenna experimentation, receiver, data rate, all that kind of stuff. But I don't have a good report from him on that to give you. But yes, we are. But nothing's cast in concrete yet. We're still trying to figure out really how we should do it, what makes sense. And I think Jeff has brought up some good ideas today that might be more doable and a little ahead of the curve.
The most expensive part is going to be your solar cell.
And Jerry has some, or at least he had some that he thought we might could use. So that was for a one use, so I don't know.
Well, you might consider deployable panels on your 1U to try to get the power up, because you're not going to have enough power. You can generate and sustain about a 1.6 watt load for the passes where you're downloading. If you go to the global star thing, you won't encounter that. It's a smaller power transmitter. So there's, you know, the first thing you talk about is your data rate coming down. The next thing you talk about is your power budget, and then you suffer with the size. So those are the kind of the order of the three things you got to worry about. You're only going to have about a half to a third of a U to put your payload in.
Right.
Because you have your EPC, your electronic power converter, you have your CDH control and data handling board, and then you have your transceiver system. Right. And they take up about, that'll take up about 2/3 of a U right there. And then you have to have all the safety stuff in there too.
Yes.
And so so then you don't end up with much space, which is why I said a 2U gives you enough room to breathe. You can actually do something cooler.
Well, we're very open-minded at this point, no doubt. So good deal. All right. Any other questions? Well, thank you so much. If you're interested, there are a few hard copies out there you can pick up, but we would very much welcome any additional input from anyone, and if you want to volunteer to help, we're certainly available to accept that. Thank you very much.
Well, Glenn? Ready? Dr. Glenn Langston comes to us from the National Science Foundation. Are you on the staff here?
I used to be on the staff.
Oh, good.
About 5 years ago. I really appreciate you all letting me speak to you today. I think it's great that as many people here are interested in radio astronomy.
No, go ahead. Go ahead.
So I wanted to talk about a work that I've done in collaboration with Green Bank, and because actually they sort of give me the enthusiasm to keep going on. Actually, I think they're a great support group for these projects, obviously. But I work at the National Science Foundation, and this is the telescope that the SUAN. I think you probably have seen this. I don't know. Has anybody seen this before? This picture of a few of Skip has, yes, and a few of so they basically had students come and build radio telescopes just basically by showing them one. They didn't give them any plans really whatsoever, except for this is a radio telescope, and that's why I've got one out in the hall here. And if I can find an HDMI cable, we'll actually run it. Anyway, so it's very doable to build this. This one you run basically with a laptop, and the key thing, of course, is a good amplifier, first stage low noise amplifier. But those are available commercially now. And so let me tell you so this is what we're trying to get to, is we're trying to get, what would be a home run for the NSF? Who cares about, Sarah, what's the NSF want? The NSF wants to stand up a national science project that is actually valuable, right? So we're looking, I think that where Sarah probably will fit in the best is in the education outreach part of a big proposal that would be probably run by universities. The NSF primarily works with universities, and we almost never make a grant to an individual person. We always the National Science Foundation makes grants to universities or organizations, like the Associated Universities Incorporated is a nonprofit organization, probably not legally different than SARA is. It's sort of a matter of, they have the same, they can run big things. So I'm a permanent astronomer at the National Science Foundation. I was here for 20 years. I was working with Sue-Ann Heatherly, of course, it's really my spiritual leader, and then Sophie Knudsen, Evan Smith, and Eve Knopf, and also somewhat inspired by Ellie too. So she's been sort of organizing us. It's really fun. It's a powerhouse to do that. So the goals of this presentation are to show that basically the Horn telescope that we have, you can see the galaxy in neutral hydrogen in like 2 or 3 seconds. So it's very, very sensitive for the whole of the sky now. There's no issue with sensitivity anymore. It's all practical. How do you build one of these things? Students use it. We want the students probably first off to see them under teacher supervision, right? So we sort of have a plan that we would, every high school would have a radio telescope and they would build their own, right? That was what we would like, because we would like to stand these up as a national facility, all done by volunteers, right? So that would be a home run for the National Science Foundation to do that. But the NSF itself does not do research. That's actually specifically in the NSF rules, in fact, how it was funded, because they didn't want another federal agency dominating the research. They actually wanted groups and outsiders. So you have to understand the NSF model in order to understand what the NSF does is we review proposals by different organizations, from universities primarily, and looking at those proposals, then we select the ones that we think, well actually usually, not even we, but we usually find like other professors, and they who happen to not be submitting because they won an award last year usually. And so then they review the proposals, and they pick the rank, and then we fund them down until our money runs out. I've coined the phrase science aficionados, and that's what I would like to see. It sort of has a political correctness sort of Spanish thing. So who am I, first of all? So I've been an optical and radio astronomer for quite a few years. I actually, I was Barack Obama's galactic astronomer for a while. Now I'm Donald Trump's galactic. Peter probably doesn't know that he has a galactic astronomy. But he does. So I'm responsible for the Galactic Astronomy Grants Program. So if you are looking for a grant in galactic astronomy, you would put in a proposal to the National Science Foundation, and then we would review that with all of the other hundreds of proposals we have. I have the lead role in outreach and citizen science at the NSF, and I enjoy software development. So unfortunately, I can't resist trying to build things, and I have terrible times with it every time. I'm just like I've surface mount soldered something just 2 days ago, and I was proud that it sort of seemed to work. But the software that everybody now in the modern software world uses this thing called GitHub. Who've used GitHub? Have you, anybody? Oh, everybody. Okay, and you're all like, you're like experts. So that's how you get your software. So if you want to get my little software-defined radio, and you have already got your new radio downlinked, then downloaded and installed. This lives on top of that. You will be able to run the telescope.
I'm sorry to say the contrast on your email is very bad up there.
Oh yeah, you're right. So jalankstow at nsf.gov. I think this slide will be on the web somewhere. You can send it down. Excuse me?
The jalankstow is the same as your GitHub.
Yes, jalankstow, yeah. Sorry about that. So first a little bit about the NSF. So the NSF operates, funds the operation. We do not operate the NRAO or the GBO or Arecibo, but your government spends about $100 million a year operating radio telescopes throughout the world. So it's a fairly big thing. The NSF astronomy budget is approximately $250 million a year. That's what the NSF, the National Science Foundation, spends. So we're proud of all of the facilities we have, and unfortunately, we actually have had, I would say that the main issue happens to be that we're actually been successful in building more telescopes than we can easily afford to operate. So that's sort of the balancing problem. The NSF is a big part of the federal budget, but by far not the hugest part. So the Department of Defense gets half of the research budget, or approximately half. NASA gets 9%, and the NSF is about 4% in 2000. So we're kind of a smaller player in the research. This is Health and Human Services and Department of Energy, and we do collaborations with NASA and DOE for certain kinds of fundamental physics experiments. We actually have a CubeSat program too. I don't know if you're aware of that, but I was involved. I'm not involved in that now, so I have to find
who would be able to tell you anything. I have the same problem, I guess, with the contrast. You can't see. So I'm now going to tell you what.
That was bigger, so I can see that.
Okay, good. Now I'm going to tell you approximately what we've been up to. And this is, again, it's not what the NSF does, it's almost just what I'm doing as a project to get ready for somebody else to take over this project, right? I am not going to do this national-wide, but I'm going to keep tinkering in my barn and my garage and all those places and build stuff. But, so this is Evan and Sophie. So it's key, really, obviously you have an issue that we're a little bit on the older side here, except for a few of us. How are you going to get younger people in? So what you're going to, in my opinion, what you're going to do is you're probably going to want to find high school teachers. How many of you are or were high school teachers? Is any of you were? So that's, I think that's the in group for you, right? To be a friend of a high school science thing would be a perfect way to be a part, yeah, or college.
We've supported high school in our public outreach, and we actually had that teaching radio astronomy, but you really have to find the right person.
Yes.
High school teachers tend to be a little lazy, and you come in with a new thing that offers more work to them, they're like,
yeah.
So you got to really enthuse them somehow, or find the right person.
Yeah, well, I completely understand. I agree with that. And there was actually a guy, Kevin Bandura, at West Virginia University, and he had to sort of solicit like a program for science teachers. And he actually did quite a complicated thing. He basically taught them digital signal processing, introduction to astronomy, but he only got, I think there was 12 teachers in the whole East Coast or something like that. So you might have to cast a very big net to get that group that you want, right? I mean, so you just go for everybody, and then you'll find a few that really will just love to do these projects. But they're going to be a select few, but that's okay, because you just want that to start off with. I wouldn't try to get, if they don't want to, I wouldn't try to, get somebody just off your next door neighbor.
Many are called and few are chosen.
Yeah, that's right. Yeah, that's exactly right. But so you can't, so this is Evan, like I said, and this is they've been through a lot of different decisions about what kind of thing to build, right? And we have we're trying to be a low cost, you can build it yourself choice, but it's still not super low cost, unfortunately. It's you have to add up all the bits and pieces. We're sort of at the $500 point, right, for a whole radio telescope, all put together and operating. By the time we put everything in, it turns out the good amplifiers are like $100 for like the really great amplifiers and stuff like that. And then you add in computers and stuff like that. But and so even they're using, this is my laptop they're using. Okay, let's talk about the actual details, right? So now, we went back and forth about how to put our designs on the web, right? And I said we should go with SARA, so I thought, well, SARA would be a good organization for this. But I think that didn't happen. They didn't want to do that. They wanted to have their own, that's a little bit of a trouble with each organization. They all want to have their own websites and stuff like that. So where all of the information is, including manuals and memos on how to build this telescope, are on the website, Open Source Radio Telescopes. And I would like to see at least, maybe there are already SARA links to that. I don't know if there are or there aren't, but there should be. We actually have SARA links to our website, their website, not my website. And so here is an example I like. So this is my son and his girlfriend, former girlfriend, I guess it's too much radio astronomy. But anyway, so you just need a horn, and you need one thing that I think everybody knows, you need a resonant cavity. And then you need good amplifiers, and then this was a coaxial cable design in the laptop. So what we've been doing, so I'm kind of embarrassed to show you this after seeing the nice one that he made, but this one, we had to go with what you can buy at Trent's, right? It has to be purchasable in a hardware store. So this is a 6-inch circular stovepipe, right? And you can't see it in there, but we had Steve White here at the NRAO, GBO, tell us it turns out you can really make a very sensitive receiver if you know where to put the feed probe, and you know what length the feed probe is. You can sort of just barely see it in there. Don't bend it, you can pass it around. You can bend it, it's sort of, and we claim our best measurements, and we somewhat repeatable, we're about 80 Kelvin with this. I don't know if anybody knows about system temperature, but that's very sensitive for a commercial. Right now,
It's about 1.1 dB noise.
yeah, and so in there now is my new surface mount system, because I take this to Alexandria. I can use this in Alexandria, Virginia, and I can see galactic hydrogen, but they're dominated by out-of-band interference. So I just put in there more filters, and that sort of increased my system temperature quite a bit. So it's like 300 Kelvin right now, so it's not really where I want to
Did you get it from Marcus?
What?
Did you get it from Marcus Leach?
Well, no, actually, I talked to Marcus a lot, or I emailed Marcus. We're Facebook friends, and but he's constantly giving me information. He's a very good guy to work with. But anyway, so this is the whole system. The key, though, is you can't just put that feed probe in there anywhere and get good. It really is fairly important that you put that exactly in the right spot. And right now, I think I've sort of crushed it, and I actually put copper tape in there. I'm giving you more details than I gave to try to get the the conductivity in the resonant cavity up a little bit, just to sort of improve it. But anyway, so I just wanted to try to give you the idea of what we actually, and again, I'm here not to tell you how to build this, but really rather to get somebody else to do a better job at this. I know that this group can do a better job at this. But anyway, I'll tell you what we've learned. But I think also to tell you how you have to. So we have this memo series. Again, this is my idea. I kind of like this sort of a light work as our memo system, because we're hoping that many hands make light work, right? So that's what our memos title are. But you need to document what you're doing, right? So we are all the way up to 21 memos. Some of them are not completely complete, but they're sort of partially. Again, it turns out bubble wrap is your go-to material for radio telescopes, in my opinion. It's really durable. It's, you can leave that horn. This piece here has been outside all winter, right? And it will run. The software and everything will run for months. So it's really, it may blow over, but then you stand it back up again. But so anyway, it's a pretty good material. If you wanted all sky coverage, it turns out, so this thing with this horn has about a 15-degree beam. So it's not good at things like the sun. It's not really even very good at Andromeda, but it's really good at the galaxy. And if you wanted all sky coverage, you would just need 180 some of these horns pointed in random different directions all the time, and you would have complete sky coverage all the time. And then you'd have to somehow figure out. I haven't got the software to put it all back in. But so what is in my devices? It turns out you need a lot of gain to make this work. I think so I actually have a degree in engineering, but I'm mostly a software guy. But everybody is probably know. So you have to have a really good semi-rigid cable going into a really good. I only really use evaluation boards. I don't do any custom. I just buy whatever the best evaluation board. So this was a good evaluation board. It goes in one side, out the other side. It has 5 volts. Has one filter here in this case. This thing is for this is H1 thing, so it has this 14 there. Everything is commercially purchasable. Unfortunately, by the time you buy all these things, you're looking at about $180, right? So that's sort of it's expensive, but that's just what if you buy this is $60. Some other things here. You can actually get different bits and pieces for different amounts, but that and this guy Kevin Bandura has also built one that is a single board for about $60 or $70, but still by parts and everything. You have to, but we don't. He doesn't. He does it for his own thing, so he doesn't do it to build so it's not commercial. So you have to figure out how to get commercially done. So we actually so this is Sophie again, and this is the student thing that was built last summer. I'm not quite sure what they're going to do. I think they're going to build more this year. And this is they built 2 of them, and again they were just done basically by showing them. And it turns out that I'll tell you an interesting thing that I thought that I was helping them. It turns out I was a specimen in their study. They actually wanted students to learn how to work with scientists. So I was just part of the, so you get a random scientist in there. But then what happens is always somebody takes charge. Like Ellie is a take charge person. This girl was this big take charge. And once they built it, they had to then report, basically give a presentation on what they built and how it worked, and people would ask questions. So you need, that's where I think you guys would be very strong, is in the receive side of this with sort of comments, right? So you could go to, the thing is you would like to have your high school build this thing, it didn't work the first time, it turns out you have to fix it. And then after that, then you have to have them make presentations, because when you're talking to high schools, what they want is leadership and project management. They don't really care about radio astronomy. I'm sorry to say, they don't care about radio astronomy. It's a disappointing fact, but they don't. But it doesn't matter, because you're still doing all of the skills, the life skill kind of things they need, is running a project, knowing how to make a presentation, and all of those things you can sell as a part of what a high school person knows. That's why they do science fairs, is the presentation business. So that's sort of what you can sell. So I keep puttering around. There I am. So here's my radio telescopes. So I told you that my first one, my wife refused to use, so I couldn't use that. And so I told somebody, I forget. But so it turns out it was best just to make a big protractor, because you have a 15-degree beam, and also forget about motors. Those are just trouble. You don't want to, like those H1s things that were done by
Drift scan.
Drift scans. There's drift scans. That's the way to go. Because then you've got a lot of money invested in this thing. You've got to worry about it. If you just keep everything low price and simple, they're also trying to give them the basics of how it works. You're not trying to, build. You're not going to compete with the GBT. You just don't have the area. You don't have the facilities. So you're only just trying to get it to work. Anyway, so there's two. So I really, really recommend this green foam, by the way, because otherwise you end up with leaves and birds and everything and snow in your horn. So you've got to put a cover on your horn. And a horn has super gain compared to a dish, right? So it's much higher efficiency. It's like 85 at least % efficient compared to a dish is probably like 35, 40% efficient as far as signal coming in. So a much smaller horn gets you a lot more than a dish does. I mean, you can build a much bigger dish, but it's hard. You can't really go beyond.
If you want a couple tips on your horn, don't use wire. Use hobby brass tube. It'll give you a better match.
What? Oh, and that? No. Well, that's a silver wire there.
I'm telling you.
No, well, actually, I actually do know about this, and because I've used all kinds of feed probes. And by far the best is that very, very, very narrow feed probe.
That is contrary to accepted practice.
Well, I'm telling you, that's if you ask Steve White what numerical code he used, we tried that. We actually worked extremely hard. I swear that's the best.
Doesn't matter how elegant your theory is or how smart you are if it disagrees with the experiment.
Well, no, but I'm telling you, this is by far the best system temperature of any system temperature.
Well, I do waveguide transitions for a living, and that's what that is actually. It's not so much a resonant cavity, it's a circular waveguide transition. And at the back wall of it, what you want to do is, I noticed the gaps you have there, your conductivity is poor. You want to take that same copper tape and you want to go along the whole back of it.
I would, except for the fact that I don't want to fill it with water. So it's tricky that, it's...
And drill a small hole in it.
Well, that's where I agree. I agree that you can do a better job than I can do. That's why I'm here to tell you can do a better job than I can do. But, so I'm completely happy to see a better one being made. Right here. Yeah, so that's, well, no, I think it is, but I want them to be able to get away, to build it on their own, right? So I can do this with a drill.
Even a 3-pound Maxwell House coffee can will do better than this.
Well, okay, good.
You don't have to make. No.
Well, you could have. You're taking over my presentation. So we've tried to. So people know about. Who knows about GNU Radio? How much time have I got left? So who's built a design using GNU Radio? So there's like several of you. Okay, so we have, and this is almost impossible to write down. So when you make this, we actually. So this is so familiar. These are my cohorts last summer, and basically we made an introduction to how to use GNU Radio if you haven't done it. And it's only 5 minutes long, it shows you, and it actually works completely with audio, so it's extremely easy to do. I would not even look at it. It's off of the open source Radio Telescope's website, so that would be where I would go to get it. I wouldn't bother typing, because you're never going to get that many characters right, you know. But it is there, and I think it's a good, it's sort of a nice way of, maybe that's, I don't know if this is what SARA wants to do, but it's actually quite easy to do videos with a Mac anyway, because, so we were sitting here talking and all the stuff, the screens move around, and it's like 5 minutes long. So finally I'm going to get to the science part of what we can do with this horn, and I know you can do it, we'll show you outside later on, maybe at lunchtime. So you know that the galaxy, I have a couple little things about the galaxy. I cannot do Andromeda. I've tried and tried and tried. I cannot see Andromeda with this horn. So I'm just using this as an example. But it turns out, of course, one little thing. So this dark line here tells you a lot more than I appreciated. This means that this is the close side of the galaxy, because the close side obscures the center of the galaxy. But anyway, but it sort of tells you which way the thing is spinning. So if we were in Andromeda at the same distance from the galactic center, we would be here. And now it turns out that this is the H1. This is from Bond and other, but it turns out most of the galactic hydrogen is outside of where we are. There is galactic hydrogen at the center, but it's not the dominant, it's not like it's all concentrated in the center of the galaxy. It's out on the edge. Anyway, it extends much, much further out. Now with this is a Lightwork Memo 18, so we have to write if you do an experiment, you have to write a memo or something. It would be better to put it in a paper, but a memo is a much lower barrier. You say, well, this is what I did. And so Memo 18, so this is 9 beautiful minutes of data here, right? And so at that point, I can actually aim at the Perseus arm and then just tilt my little protractor down to different degrees, and I would make the observations. And you can sort of vaguely see here, it's a little bit too tight, but that the signal decreases as you go. Now it turns out the Earth, its North Pole, of course, as the North Pole would spin around, but it points off at some kind of a funny low galactic latitude, 22 degrees. So when you move in elevation, you move out of depending on where we are in our rotation of the Earth, you move in or out of the galactic plane, right? And so it turns out that at this time, so what I would do is take 30 seconds of data. So each one of this is 30 seconds, each one of those lines. But you see how, the signal to noise is just fantastic in 30 seconds. You can actually very easily map the galaxy in 30 seconds with this thing. And so you see that when you're looking at the lowest galactic latitude, so this is the longitude, so it's not towards the galactic center. This would be 0 to longitude. This is 90, 180. So we're looking out of the center of the galaxy. The azimuth and the elevation, so we started out at azimuth pointing south, 90 degrees, straight up, down to 10 degrees elevation. It still works at 10 degrees. This has a baseline subtracted, by the way. The system temperature goes way up when you're looking at those, because you're looking mostly at the ground. But anyway, you see it turns out we're looking at the Perseus arm the whole time here, so it's a little bit less interesting as far as what you get. But that's just a few 30 seconds of data, right? And you just record it, you stop, you move, you run outside, plug in your, you move the telescope, you run back inside, you turn it back on again. But you can do the whole sky. You can actually, if you had a crack team, you could do the whole sky in a night, but nobody has that kind of attention span. Because you can move the telescope all over the place, then you forget where you are. About two hours is the maximum I've ever seen anybody observe at one time at the horn, but that's how it works. So this is the predecessor observer. No, this actually is the newest observer interface. So this is with an AirSpy Mini, which is a certain one of those SDR dongles. This is the code that I've written. This is what you would get if you were to download that, and you already had GNU Radio installed. It won't do anything without GNU Radio. My code is only 1.5 megabytes, so there's maybe a microsecond to download it. But so what it does is it allows you to either record. You're mostly waiting when you're fiddling around, and if you have the telescope, you need to calibrate the telescope. How do you calibrate? I have no no moving parts inside this thing. There's no on-off switches or anything like that. So I just pick it up and I put it pointed down at the ground. And because it's a horn, that works perfectly. A dish, it's a pain in the butt to do that. You really don't, it doesn't work. You want to use a horn. Anyway, but this is the hot load signal here, so it's painted red. And then this was the cold load, because you try to pick a spot that happens to be fairly far from the galactic plane. And this was some random other spot, which is the reference plot. So you can record these things as you go. And then, so what, anyway, let me keep going. So this is when you actually do the look at the galaxy, and you look at different places. So this is the signals. This was well, this happened to be a couple years ago almost now, a year and a half ago. Different spots on the different latitudes and longitudes, and you see different structures. Now, you do need a vivid imagination to turn these curves into arms of our galaxy, right? They don't look like arms of our galaxy, right? You have to be able to convince your student that those are arms of your galaxy, right? And so that's a little bit of a challenge. It's sort of a bit of the presentation you have to work with. And when you look at the North Galactic Pole or South Galactic Pole, you still see, this is the South Galactic Pole, you still see signal, so there's signal everywhere in the sky, but it's, these are actually longer averages. These are probably like 5-minute averages. I'll show you why that we do that. So to get the 5-minute averages, you have a tremendous signal to noise, and you can see signal. There's no place where you don't see the galaxy if you average for 5 minutes. So this is what this is the thing that you would download if you followed that. You have you put your little name in it, and then you have some block that says where to get your data from. And then you say, turn it into a vector, which this does, and then it turns it into a magnitude. And then it does something special for radio astronomy, which is a median filtering, to get rid of short-term interference. So these blocks take 4 spectra as they come in. So these data are coming in fast and furious here, but it takes 4 spectra in and gives 1 out, which has been RFI rejected. It does it again, does it again. So you
Software integration, right?
Yeah. And so you get down to about like a second. By this point, my data rate's 1 second, so then I can eat that data on a very weak computer. I use this Odroid thing. So again, what happens then is you don't have, you're all busy. This is your hobby, right? So you can't be out there all day. So what you do is, this is a right ascension plot, and this is a declination plot. And so what you do is you go out and you set your telescope up, and you go into the house and have a cocktail, go to bed, and whatever you do. But then you come back the next day and you've got 24 hours of data, and you just keep doing it and after a month goes by. So I would imagine my goal would be that the high schools they wouldn't do a lot. They would just set it up, and then they would do whatever else they're teaching, and then they would slowly accumulate. So, and you have to remember, it's a little bit of bookkeeping just to remember where you are. And there's some peculiarities. I'm not quite sure why this doesn't seem to match as well as it does, but I think it's because the outer galaxy is very bright in galactic hydrogen. This is the outer galaxy up here. This is right ascension declinations. This is the horizon for me, and the North Pole's up here. And I wrote this software. So this is what, if you then transform these coordinates into galactic longitude. So the galactic center is here, and it seems like there's, but anyway, so the North Pole moves over here. This is below the horizon, which is difficult. You can't do anything about that, except you have to get, so at this last week's conference, I met somebody from South Africa and she wants to build one of these, so hopefully we'll get that filled in the next time around, so that'll be good. But anyway, so she'll have to do that. But that's what you can do with this system. So I'm actually, because I had a little bit more time than I actually did this in 20 minutes at a conference last week or 2 weeks ago. So I'm going to tell you this. So what is our approach for progress at the National Science Foundation? So we are out there looking for groups who want to put proposals together. Now, I don't think that you guys are ideal for that, except I think you would be a very strong partner in a university, like the people who are already from the universities. You are very strong partners. So you can actually look, I mean, the NSF requires a outreach plan. Like you want to reach underserved. Unfortunately, very few of you are underserved here. But anyway, so we need to what you like underserved groups. Actually, like some people even do all kinds of crazy things. Go to prisons and teach, and that's part of their research project.
We're from Appalachia. We're okay.
Yeah,
We're
well,
there.
if I think you can make that sale, but you have to do it, and you have to find somebody to team with. Because you really don't have the, you need to find the teachers, or you need to find, you have the expertise, but you don't have the way of getting to the community. You need to get to the community for you to be a strong partner, right? You could do elder hospitals or something. I mean, that's one thing that they also do. Yeah.
Were you planning to do a demonstration?
I am, yes. Oh, the HDMI cable? Okay, thank you, very good. So, I just want to shut it up, we'll set it up and show you. Well, I have to say I'm going to finish my talk, but I'll tell you what before. What I'd like to do the best with the school group is give them usually again, somebody will take charge and they'll look at and then you hand off the telescope, it's light, so you can move, and you can use it like a gun to sort of look at the different, and then you'll see after, you can tell them to find the galactic plane. So the sky is a bright, as you know, a very bright radio stripe. And so then they'll be looking around and see, right, she'll see the ground, and so, let's look at somebody, see the temperature go up. And then every so often they go, oh, I see it. And then you can get them to find the galactic plane with this horn as sort of in a freestanding thing, because you can figure out where it is by the signal going up and down. You can you'll see that if you, but anyway, that's my little trick I like to do. It's sort of light enough you can do that. But again, so back to why did I come here? Because I was looking for you to build teams of maybe a different telescope. I mean, Elliott's got a good telescope she's pushing, which is a loop antenna. And whatever, maybe an alternative that's more sensitive or less sensitive, or maybe as a ground tracking station for space, maybe you can imagine. I kind of would like to have, in order to have a square kilometer array, right, a square kilometer surface area, it turns out there's 30,000 high schools in the country, right? So you need about 7 meters of dish at each site to have the whole square kilometer. But you can do it. The GBT can be done in a fraction of that one. Anyway, so they only need a few dishes to get up to GBT sensitivity. But it needs to be a big plan that we would like you to do. I mean, that's we're the National Science Foundation, not like the Rural Science Foundation. And so anyway, that's what I'm sort of urging you to do, is to find a way of finding groups to work with that will do these big projects that will actually advance science. And I have some ideas myself that I would like to put forward. Probably like cosmic rays is one particular area where you can use little telescopes to get the cosmic ray flashes, because that already is known to work. And probably with this kind of telescope you might be able to do something about it. But anyway, so this is sort of a step backwards about the NSF process, is where I'm going to go. I'm sort of adding in the NSF process to this. So the NSF does want active citizen science. It turns out the NSF does not want to fund citizen science, though. They want to fund research in citizen science. So if you say to the NSF, I'm an astronomer, you go to the education department and say, we want to do citizen science. They say, that is great, go to the Department of Education. Because it's not, NSF does research. So you would have to sell them something where you're doing some new aspect of education that you want to study. So people never get that, because it's not doing citizen science. That's already known to be successful. So the NSF is not interested in funding that. It's only research in education that is fundable at the NSF. So you have to find out some new way. And I think you could sell, if you're putting together a whole nationwide network to do research is some community thing. That might be sellable at the NSF, but only if it's new and it's sort of a new aspect. It's not just doing the same thing over again. So anyway, we need to get, I think you guys have great capabilities. We probably need a science leader to do those kind of things, that would be the science person who would actually guide the science side of your research project. you know, because you're the outreach side of the project. I think that would be the only way it would be likely to be successful. If there's a science side, and then you guys are the outreach side. That would work. So, how do you write a proposal? Well, you find somebody who's already done it usually, because you know, write a proposal. You find out what's already been done. You say, well, how you can build on what has been done, and you know what you have to. Probably the key thing that you have to say at the very first is, why is this work important? And you have to write a proposal in a way that you are excited, and you have, because the key thing is you're presenting these amongst a bunch of proposals that everybody else has already written great ideas. So unless you can be excited about the project that you want to do and communicate that in your proposal, you're not going to win. You're never going to get to the top. You have to be excited. It has to be the biggest thing that's ever happened. You know, it's got to have a selling point to it. And why are you the right team to do the work? How are you going to do the work? And why are you do you have the right team? And I think probably you have to like build that team. That's what you do. So the NSF. So what does the NSF do if we don't do research? Some people ask me that. And so what we do is we write solicitations for proposals. And so what you do is the NSF has this idea that we want to do certain kinds of things, and then we wait for proposals to come in. But we give some outlines, a thing called a solicitation, and you write a proposal that's responsive to that solicitation. I'm going to tell you about two, and then you're either recommended for funding or declined. So get a great idea. This is sort of a repeat of what I just said about you get a great idea. Make sure you have it, and you have to have an assessment plan too. I don't know if you're aware of all these things. There's gotchas. If you don't know about that, and you're writing a proposal, you're sort of done for. You have to know that all these things, you've got to have a plan to judge. It's sort of like you were talking with Project Jove. I mean, that's really relevant. And how do you have it? You want to. I think Project Jove is a great idea, but you really do have to follow up on it, you know, to get more money, because obviously they want to see, you know, how is it working. And you have to write that into the proposal. And I thought your suggestions about deposits are a good idea. Actually, I thought that was a reasonable. So there are many different types of proposals. Where I think that this would fit the most in is in a thing called a RAISE proposal, which is a kind of it's called interdisciplinary, which is also a fashion word at the NSF. Like it's sort of, instead of just being radio astronomy, it's also education, and it's engineering, and those kind of things. What you then want to do is it turns out you write a proposal that has that, and you just need 2 program officers to say it's a good idea. There's sort of a quality. So I would be willing to write a letter saying it's a good idea to do any kind of radio astronomy, citizen science, but then you would still need to get somebody else who's not me and not vested to get the idea to be able to then write a full proposal. Yeah?
Question. So, you know, we've written ILI grants, we've won this stuff, we've won NSF grants before, we've been through all this process. But you began with the talk about low-cost radio astronomy stuff.
Yeah.
Okay, and you're talking about a $500 thing. Nobody's going to write a grant for a $500
Yes,
telescope.
that's right. Mm-hmm.
So I'm trying to...
We wouldn't even look at that $500.
2 concepts here. So are you advocating that someone should take this on and write a grant to produce 1,000 of these things? So
yes, that's what I'm saying.
I'm saying...
I'm not really even saying, I'm just saying I'm a hobbyist who built a radio telescope. But my job is not that. It is to get citizen science done to help encourage the community to do citizen science by applying for grants at the NSF to do it.
Because if you're advocating that sort of approach, in that someone would take on this project or some group that they would build a large number of these, then to provide them to students, then things like an integrated RF package that could be designed and built and made cheaper could be possible. And that might be one of the aspects that separates it from buying pieces for mini circuits and putting them together.
Yeah. Well,
to follow up with his question, just so that I'm clear, the NSF would look more favorably if one person was going to say, hey, I'm going around the country and putting these in 500 different places. That would be something that
that's the kind of thing I could imagine being successful.
Okay.
you were always being competed. They would try to find some.
Well, no, there's a lot of competition, that's not the issue, I understand that.
Yeah, we're not trying to put you in a corner, just trying to figure out what you're suggesting.
But the idea is that you make a lot.
Okay, well, yeah, that's right. So I'm sort of done, I'm really in the question phase anyways. Let me just tell you that you can't just send a proposal, well, you can, but usually it doesn't work if you just send a proposal in. It has to have, so RAISE is one. You'd have to go look, it's a huge document, you read all the fine print, you would then submit the proposal. GOLI is this academic liaisons with industry. That's another one that might work for you. Those are the places that I thought would be the most likely for SARA to have an in at the NSF. That's the legit. So, and there's grant opportunity. So that, because I think that this does have, radio astronomy really does have a lot of industrial applications, we know, and a huge economic impact.
Remote sensing in general.
So,
big money.
Anyway, I'm just going to skip all that, so you can't read it anyway. So who do you talk to? You talk to me. So you have to make. You have an idea. You need to build a team. I can help with the idea stuff, and sort of maybe the team you're going to have to find yourself, but I can maybe make some suggestions if it. And you can't even submit the proposal. You have to find your research. I think somebody at SARA could actually be the sponsored research office person. You would have to figure out what the rules for that are. Every university has that, but it'll probably be easier to do it through some university. You'd probably like Dan Reichert or you guys.
Could you go down to the community college level, for example?
Anybody can submit a...
No, but I mean to be favorably accepted. So an individual would have the toughest time, a university would have the best time. Would a community college be acceptable?
So we get small, there is sort of a little bit of a research for undergraduates. It's not a set-aside, which is a big thing. Set-aside means it really is money, but it's sort of a target, so that the targets can either be met or not met. But it's certainly doable when you could do that, apply at any level. I mean, the USRA and different organizations are just to put the environment together. And yes, you have a question?
Oh, well, I mean, I have a recommendation. So I'm a grad student in astrophysics, just doing observing on the plane. But
what do you got to do for a job?
In undergrad, I worked with NASA Space Grant, which also does a lot of outreach, a lot of good stuff like that. And each state theoretically should have a space grant office, and they could be the science aficionado.
Different thing though. Space grants is a whole.
Well, it's a whole different thing, but they could be the science aficionado. They could partner with SARA, and they could provide there's probably some Larry's 1 or stuff grants before, and they can help you guys out with this. I mean,
it's just finding the, so that's certainly
finding
a
the
good
right
suggestion
team for this NSF.
So it could be that would work. I mean, that's how it could work.
I'm just thinking about how people could, because getting into a university and getting them interested in doing something is typically difficult, but at the smaller scale schools, you would find more. And I found space grants, for example, really tough. They usually have all that money earmarked, so they don't want anything, and if they're not corrupt.
Well, there's an in-group who has that.
That's right.
Yes?
I just had a quick question. So you're talking about a national or project level. Could you, like, for instance, Ellie and I have been talking about just the state level, incorporating multiple colleges that she's been in contact with are interested. Would a state level array, so to speak, be something that?
Well, anything like that would be, I think, would be great. You could imagine a lot of times they may not. The NSF wouldn't go for the whole 9 yards of $10 million to build. They might go sort of at a sort of prototype grant kind of thing.
So like outreach, if it's West Virginia, so rural.
Yeah. So that could work. You could actually even go. A lot of times you can apply for a meeting grant, a science-based meeting grant, and those can be fairly big, like $50,000, and those don't require a panel review. So you can then, if you had something like, you could put it together a credible, like a smaller university. Like I don't know if you, I'd not heard of University of Richmond, Virginia. They're probably a big place, but I wasn't aware of them. They did a conference, and but I would probably, you'd be best off. You couldn't do it as yourself. You'd have to find the university who would want it, like Marshall could sponsor it, something like that. I'm out of time. I got one more minute left.
Any more questions? One more question? Because we're trying to keep on schedule.
So I do. So actually, I tell you. So I've got I built a wood base kit. I know that nobody wants to build a wooden base kit, but I built one of those just to put together. And I've got, I was gonna, if anybody wanted to build their own horn radio telescope this evening, we could try that. I've got the most of the parts. And we'll do a little demo at lunchtime here, just to show you what you can do.
I just wanted to, for Dr. Langston, I want to first apologize. I realized I put the 12th instead of the 11th. So for those chronologically not challenged, which I am, but I just wanted to thank you.
Oh, boy, thank you.
All right, Dr. Rich Russell, our next speaker. Dr. Russell comes to us from Colorado and the Deep Space Exploration Society. And why don't you go ahead and just give us background.
Okay, Rich Russell, I'm just out of as the president of the Deep Space Exploration Society. We are a radio astronomy group in Colorado. We have a 60-foot dish on 11 acres of land, an old tropospheric dish that they've been upgrading for the past 10 years, 11 years. And they've just got it working. We've got a hydrogen feed on there. And we've been taking measurements. We've been collaborating with Skip Crilly. You'll get his presentation this afternoon on doing dual measurements, simultaneous measurements with a 40-foot dish out here. So we got a lot of good stuff done. We are basically like SARA. We are a group of people that are just going there and getting a 60-foot dish, which when we originally got it, all the copper was removed, the motors weren't working, and they basically returned this thing to life, and it's now working pretty well. My background is I'm a retired Navy submariner who shifted to building Navy spacecraft, who then shifted in my contractor years to building big ground stations. So I used to be the chief architect of the Air Force Satellite Control Network, which has 13 dishes all around the Earth. And then I retired from that, and I figured out what can I do for fun? Radio astronomy, and radio astronomy is kicking my butt. All right. So my goal was to originally start with SuperSids, a Radio Joe, all the basics, and trust me, that's getting me to the point where I actually think I know what I don't know. So it doesn't mean I know anything else. And I'm very much like the last speaker. My job at the Deep Space Exploration Society with all these technician guys who know how to build things is to build a lousy prototype that sort of works. They get mad at me and they fix it. And I get up with this, we get up with this great thing, but I do it because they don't think, they just hate the way I build things. My Radio Joe had I followed it exactly using plastic rods, and it was bending and all that, and now these guys put up big steel poles, right? Because they hated the way I did it. So my sort of goal is to be an amateur astrophysicist, by the way. Last year, you guys, when I presented this, I went, hey, the eclipse is coming up. I think that with a SuperSid, you're going to see a bump. Here's my analysis of that, and to be an amateur astrophysicist, you have to predict something. So I did it right at this meeting right before the eclipse, and now I'm ready to present my results. It's in the journal, the month after I published the results in the journal, and it worked. So I'm an official amateur astrophysicist. I predicted something and actually came to pass. So I'm following up, this year I'm following up. I'm going to predict something else, and it's in galaxy stuff. So I'm glad you were right in front of me, because I'm doing galaxy astrophysicist. And I'd like the check from the NSF after the brief. Okay, so what did we get from the eclipse, August 21st?
This is my super SIDS output. Now the nice thing here is, and I don't show the plot, in Colorado Springs, the actual transmitter is almost exactly halfway between where the eclipse was going to do the pass. And so I've had this thing, I've been taking data for 2 years, and now all of a sudden I get this eclipse that's going to pass halfway between me and the thing. So, so I came up and I said, hey, all an eclipse is nighttime, this is what happens at night. It goes up very fast, and in day it goes down very fast. So I said, hey, well, based on this, and when the time of the eclipse is going to happen, here's the rate that's going to go up, and here's the rate that's going to go down. So I actually predicted that it's going to look something like this. And this is the actual plot that I actually got. And to show you how close I was, this is the actual, and this is what my predicted was. And that this is, I mean, this, you can't even tell on this chart here, it'd be just barely thing. So it worked. The data analysis I did worked. That it's actually, an eclipse looks very much like a day and a nighttime transition. It's just shorter. Okay? And there's a couple of little variations. You get really down to it, the slopes aren't quite exact, so that's some follow on. The other thing we discovered was that I have a big mountain called Pikes Peak to my west, that I actually get different slopes. That slope is different because I have Pikes Peak there. Guys in Arizona get more of a steep up and then steep down because they have no mountains. So somehow the mountain's affecting my rise and fall and my super SIDS data, you know, affecting the ionosphere. So I wouldn't have gotten that with the eclipse because the eclipse didn't have it. So anyway, so I got that. Just for things, I am in the AFSO. There is an AFSO Super SID observing team who's been observing for 10 years. I've been entering my AFSO, my Super SID observations for the past 2 years. And these are the other observers that are in there. And basically, they all saw the same thing. You know, this messy guy here, but fundamentally, they all saw the thing. And one of these guys is down in Mexico, etc. Finding some research, guys who have long baselines like in Antarctica, there's actually some guys had a negative drop. So there's some kind of a phase variation there. And just to throw that there is new science here, all these guys had this dip right here, which is pretty much just after the eclipse. Everybody had a drop, and I have no idea what that is. But just notice, every observer had that. So there's something going on after an eclipse that will cause a steep drop, and then it returns. So I throw that out to as an amateur astrophysicist that there's new science here that I have no idea why it's doing it. We've got a lot of observers that saw it. Okay, also on super SIDS.
Rich, what was the time delta between the end of the eclipse and the anomaly?
Let's see. Let's say 1800's the center of the eclipse. 1912 is the anomaly. So here is so you see the slope there? So right about here was the end of the eclipse. So it's really close to the limb, the end of the limb. So it's almost the exact end of the eclipse. So there's something that caused a drop in all the super SIDS data, that same drop. And it happened to everybody. So I thought it was just mine. Didn't know why, but maybe it's some kind of a flash, or you saw something that just as that limb exited. I don't know. But it's an interesting phenomenon. Next, in 6 years, when we have another eclipse, I'd love to sit there and have people look at that and zoom in. Anyway, by the way, I do highly recommend this in 6 years for the new eclipse. I mean, we should be able to see it in North America. But theoretically, you guys should be able to see eclipses even though they aren't passing through you. You might be able to see an eclipse. You just have to find a transmitter that's passing through an eclipse even though it's not North America. So think about that if there's other eclipses around the Earth, and there always are, that if we can sit there and find the right transmitter or receiver combinations, we can go do this around, you know, not have to wait for the North American eclipses. Okay, questions on the eclipse? basically, I told you guys I was either gonna not ever bring this up again, or I was gonna be a folklore hero last year. So I'm deeming I'm an amateur astrophysicist, and I'm folklore because I predicted this, and it worked, okay? Now, it's interesting that, so I send these charts in all the time. By the way, this is called SID Grabber. You can download it on the AFSO website, and what it does is it pulls up all of the data from the National Weather Service and plots where the flares are and what the levels are. So this isn't me telling you what that is. It's basically, if you're online, this SID Grabber will pull your data from your super SIDs, and then it'll overlay what the actual measurements are that the satellites are giving you from GOES. And so on this day, we started to see some X and M flares. Now, an X flare is the highest flare level, and theoretically 1.9 is the highest flare. I'm sorry, 9.0. They go in 0 to 9. 9.0 is the X 9.0 is the highest flare that they've got a record for. All right, and M's, so it goes X, M, C's, B's. Okay, so when you start getting, so normally you get C's and B's, which are down here. You see the little bump you get there. M's are second highest levels. X's are your highest levels. So here, September 7th, I saw an X 1.3 flare, and that gives you a huge thing. And basically the way a flare works is, flare happens, it ionizes the atmosphere, causes a reflection from the submarine transmitter, and you get this big burst up here, and then basically it recovers and it gives you this nice shark tail or shark fin approach. Okay, so that is what you're looking. If you do super SIDS, that's the classic what you're looking for. You're looking for that shark fin. All right, that gave you. And then if you use SID Grabber, you know exactly that yes, they did have one there, and so you can sort of correlate it. Because sometimes you get trash here and you're not sure if you really got one or not. But this sort of tells you, yeah, you actually had one. So next 1.3. Boom. September 10th, an X 8.5. This is what happens when it takes out the entire ionosphere for the entire day. All right? And so this is, if anybody has super SIDS and hasn't recorded, go look on September 10th, right here at 8.5. Remember, it only goes to 9 in the scale.
Well, it does go higher, but there's no letter.
There's no letter, right? Yeah, yeah, but so you got an 8.5 here. So anybody who did super SIDS, this is why I like super SIDS. One, the software is easy. I've got it. It's a little snuff can receiver. I've got my little wire thing, and that wire thing I've gotten great grief about from all my guys because I built it. And I'm a lousy builder, but I put a lot of wire in a box. But I've left it out for 3 years, and I get good data. Okay. So anybody look at that. So you got an X 8.5. And I also documented all this in the journal.
Now, how is that flare different from a lot of others? Because I had a system going at 408 megahertz, and it basically pinned out the receiver that day. Most flares don't even show at 408 megahertz.
Well,
I mean, you know, it pinned out right at the time that the super SID people were saying, yep, it's there.
Okay.
And it pinned it.
Okay.
It was strong.
Well, okay, yeah. So the way super SIDS works is we got a submarine transmitter at 25 kilohertz. So it's very low frequency, right? And then the ionosphere basically goes up and down with day and night variations. As soon as you get a flare, it ionizes it, and it causes a reflection to happen.
Right.
And so you get this great big signal jump. And by the way, it should be, this is why at night you got the highest power here at level at night. But in the daytime, it drops it down to nothing. Well, this basically makes it look like a nighttime. And then it recovers and it gives this nice flare. This is the, I think that, I've never heard anybody else get a nice, pretty signal on super SIDS like that. But if you've been recording, look for this date and see if you've got it. And I think it's only because you're doing bistatics with super SIDS.
No, see, I was doing 408 megahertz, so I was getting direct radiation.
You're direct.
I was getting direct radiation from the sun. And most of the time, you know, I watched the radio astronomy group, and see people, oh, we saw a flare, and I take a look at my results every couple days before the data recorder overflows. And since September 10th, I've not seen another thing. I saw one thing that might have been a slight effect, but that one, it just...
That blew it away, right?
It was strong.
I've been, this last, 6 months, there's been hardly any activity. My thing's been dead for the last 6 months. And I keep thinking it's my wife put clothes on it or something. It still looks good. It's still where it is. Yeah, but I think it's just the sun. The sun's very non-active right now, which ought to make the ham radio operators really upset. Yeah.
So when the flare happens on the sun, when do you see it on the receiver?
I don't know.
Is it 11 minutes later?
8 minutes, at least, and then,
That's when you see
It's caused by the X-ray, so it's 8 minutes.
So the ionization happens pretty quickly.
Yeah.
It's just that the
But
case
it's
will be
not 2 days later?
No, no.
oh no, it's almost
It's
the
a
same.
CME type stuff.
It's almost immediately.
Yeah.
It ionizes, it just slams the ionosphere, and then this VLF signal from the submarine transmitters. That's really what you're seeing. It's got a beautiful reflection path.
Sure.
And if you saw it, just like you saw my Eclipse one, if you had, if you were at different locations, you would have a different amplitude based on, almost what's your max nighttime conditions. But when it really slams it really makes it reflect, and now you get almost all the signal from that, and you get it beautiful. And then you see, the nice thing is it's a recovering here, so it basically becomes non-reflective. It gives you this nice, pretty exponential decay curve.
So it enhances the reflections,
Right?
right? Whereas in ham radio, I'm a contester, and some weekend I'm contesting along and making contacts all over the United States, and all of a sudden, it shuts off when a flare occurs. So what's happening?
Depends on what you're bouncing the HF, you're doing HF, what's it bouncing off of, and what happened to that layer?
Yeah.
So
This
you're going off F layer, and D layer became ionized and absorbed.
I kind of thought how this worked, and people are going to tell me, since it's been years since I've been here, but I remember when they got started with Super Cities and they built all this stuff back in the day. I thought that you were listening to the VLF beacons, essentially the submarine transmitters,
Right.
and you were observing them at a certain level. And then when you had a solar flare, it ionized the ionosphere greater, so that you had greater depth of ionosphere. That moves the plasma down closer to the surface of the Earth, and then you got less signal.
You get more signal. You get more signal when you get a flare.
Okay, tell me, Tom.
Over here.
Yeah.
I believe, I don't know this for a fact, but I believe what happens is the D layer is ionized.
Okay.
And these frequencies are such long wavelength that I think the plasma frequency of the D layer allows the
So it's the D layer that's now reflecting as opposed to the E layer which gets slammed
It
down.
reflects the VLF, but it absorbs the higher frequencies.
Yeah,
So what are you saying, Tom? You're saying it does get more reflective or it gets less, or you get less signal?
You get more reflection, and because it's the D layer, it absorbs the higher frequency, but it actually enhances.
See, but the whole idea of the submarine signaling system is that propagated around the entire Earth. That's what its use was for. And so you were able to get a signal anywhere all the time, basically.
Well, I think normally we're receiving ground wave.
Right.
Okay.
Yeah, the reason you have,
that would make a difference.
Being a submarine ex-navigator, and I'm going to go into that in the next talk, the reason is because it can penetrate the ocean.
Yeah,
I don't have to come up to the surface to get comms, even though I have to, it's 1 bit per 100,
Just tells you to come up to satellite.
Yeah. And my wife she only had 30 characters to send me a note once a month. And that took, 20 minutes to get her 30 character thing in. And so she lets me know about that. So, it's like Twitter, slow Twitter.
I believe it's 50 baud.
Yeah, it was really low. Then as an officer, you had to sit there and review these things because wives were divorcing guys, and they had 30 letters to tell them that they're divorced, and you had to sit there and say, huh?
That's a short Dear John, isn't it?
He's not gonna see that one. All right, yes, sir.
Back on the last graph, how do you know what frequency you're looking at?
This is, because you picked NML. NML is was the transmitting station. NML is at a certain frequency.
Okay, fine.
Yeah.
But how do you know your radio's picking that one up? I'm.
Okay.
This is one of the things
It's
that.
FFT-based radio, right?
Super SIDS records based on the frequency, and if you see the spectrum plot, it has the different spectrums, and it records that, so it picks the NML frequency and gives you the NML one.
That's that special software.
The software, right.
Okay,
And so it also,
or whatever you call it.
it also records a different frequency for the other transmitters around. So you can actually, depending on which one you pick, you have a different geometry.
Sure.
But if you use the off-the-shelf software, it shows them all.
If you use the off-the-shelf software, you can pick the different stations too.
Okay.
It just doesn't give you, this. It doesn't give you the data from the GOES. And I just, in fact, the AFSO guys want you to use this because what I can do is I can sit there and I can click this point, that point, that point, and it'll actually put it in a report, and the AFSO guys take all the reports and they can automatically absorb it and then analyze it. So this is they basically made a tool that they can convert that into digital and then report on multiple observers.
Is this a talk on Super SID or?
It's not. This is an update.
What's that? Because I have an antenna question.
Sure.
I want to build a loop in the attic of my house that goes around so it'll be horizontal rather than vertical. What's the upside, what's the downside to that? Because it'll be about probably, a 400-foot loop.
It's, all the ones have been vertical, so the question is, do you got vertical and horizontal, you're going to lose gain?
I believe the electric field is vertical.
Yeah,
the electric field.
You're not going to couple to the field properly by doing that. That's the problem.
Yeah, vertical and horizontal, I mean, that's almost 100% gain loss. So I believe these are all vertical transmitters. At least all the super SIDs have been vertical. So I don't know about 100%, but that's
probably not a good idea.
Yeah, I would say just go ahead and put a small one with a lot of loops on it, vertical in your attic, and you probably get better gain. Okay. I was trying, as your new amateur astrophysicist, I've been, my goal was, and we've been doing hydrogen, and was, hey, and as a navigator, an ex-navigator on a submarine, which I believe submariners should be the new astronauts because we've got a nuclear power plant behind us, we're in a tube with a lot of guys, smelly guys, and we've got things outside us that are bad, right? So the perfect, and we go out long periods of time, and it's just, we're the perfect astronauts, right? And I have nothing, I can't even look out the windows, right, except this little periscope, right? We're the perfect astronauts, everything's by sensors, right? So I had to go navigate across the Pacific, I'm a Hawaii sailor, navigate across the Pacific without ever seeing where I'm going. And then get back, and then surface and realize that I'm at home port again, right? So we did that all the time. So that's exactly, so I sit there and say, how can I use that theme in my new astrophysics career, amateur astrophysics career with you guys? So we do hydrogen, and we do velocity measurements and Doppler shifts. So I'm very interested in the rotation rate stuff, okay? So what I want to show here is that if we take hydrogen and measure the rotation rates, your classic is how fast, your Earth's going around the galaxy, and you're measuring hydrogen at a certain galactic latitude or longitude, and you're seeing a velocity jump, right, based on how fast the relative speed is between the two objects. So I wanted to go turn this hydrogen measurement into a navigation aid for galactic, travel. And what was my theme there? We've got somebody from, we're actually doing this at DSES and SCIP, who's got, we're out looking at 40 Eridani, SETI. So if a spacecraft's coming from 40 Eridani and coming toward us, what galactic sources would he use? You know, what would he see from hydrogen in order to use as a galactic aid? All right, so that's my whole thing, right? As a navigator, I want to, if I'm coming from another planet in the galaxy, what would I see? And none of the math currently is worked out for not being on Earth, right? So this math will convert it so that you could be anywhere in the galaxy and you can convert your Doppler measurements for any of these galactic sources from wherever you're on Earth and use it in transit. Now, I don't go into how you got there, right? And you didn't use warp speed to get there. You just happen to be plopped somewhere between Earth and Keed, which, by the way, is Vulcan for you, right? You're plopped somewhere in between there. You got there somehow. What would your hydrogen measurement be to tell you that you're actually there, where you're on course or off course? That's the goal of this paper. Okay, what's the math? Because nobody's done that because nobody cared that they were here. They always cared that they were always on Earth. Okay, so that's the goal. So first you get the rotation rate formula. So we're going to go over basically all that. Then what's your geometry for galactic travel path? So we also have to account that Keed is actually below the galactic plane. So we're going to travel from the sun to the Keed. And we're going to use that Doppler data to figure out where you are in the galaxy, where your spacecraft is in the galaxy, okay? And then I'm going to say, based on that, I can actually figure out, you guys sailors or pilots, right? So when the wind's blowing, you're pointing this way, and the wind's going this way, you're pointing that way to go straight, right? Well, the Navy does the same thing, right? So now a spacecraft, is all this your galactic rotation actually like a current moving you? Right? Because you're going 220 kilometers per second is the rotation rate. Well, if you go past, outside that gravity, you got all that pushing you, and are you actually being pulled with it, or are you actually being left in the dust because you have no current? And meanwhile, everything else is keep moving off. So I'm trying to answer all that. So we got course velocity, galactic current indicator. So I can actually determine, based on this, how fast my spacecraft is going based on the galactic center. And what my velocity is, if I'm off course or on course. And I've got issues to be solved. There's a couple, like, how did I get there and stuff. And then I got a couple future projects. Okay, and went over this. There's actually 4 quadrants. Here's the sun. Here's the galactic center. But our current galactic thing is based on the sun being the center of the universe. All right, we're going back to, Aristotle and all those guys, Ptolemy, and galaxy stuff. We want to be modern, so we're going to have to shift this to the galaxy is actually the center of the universe, not the Earth. Right? So I don't know what the galaxy guys were thinking of that they thought that they could go back. But anyway, so right now, the sun is 0, 0. And then here's your galactic coordinates. And then this is the galactic center here, and from a latitude point of view, you basically got up and down the galactic planes here. So Keed's actually down a little bit in the galactic plane. And that's important because this thing's rotating like this, or like this, and the lower level planes are not rotating at the same speed. And Keed, which is Vulcan, is in a different rotation rate than the Earth is. So I was going to fly there. I've got to go fly into a different rotation rate and go actually get pulled. What's keeping me in that same rotation rate? All right. Now realize both of my pitches have a lot of math in them, and they put me right before lunch and then right before dinner. I must tell you. So if I see people nodding off because of lack of sugar, it's okay. Okay. I teach master's degree students, so I'm very good doing that. Okay, so a little math and a thing. If you're going to do galactic rotation rates, and here's the sun, and if you were between the galaxy center and the sun, is a different formula than if you were out here. Right? So out here you can have stuff, but it's a slightly different formula. Right? And so the velocity you measure on your hydrogen measurement here is a combination of the velocity the sun is making toward that object. Say this is the object you're measuring hydrogen in. It's the combination of that, you going in that direction, and this coming in that direction or away from you. And that's your combined velocity or Doppler shift. So it's all about Doppler shift, okay? So that's your VR. Now this here is your contribution of your hydrogen interstellar mediums, basically ISM. That's your contribution of that going away or toward you. And this is the contribution of the sun going around the galactic center toward you, right? So that's VO. VO is we're about 220 kilometers per second around the galactic plane there. So anyway, this is the distance, and this is galactic latitude. All right. So that's the basic formula. There's also another formula for if you're outside the galactic plane. And by the way, T is right here. So I had to go get this formula. Now I need to derive these. These are well documented formulas. But I had to go convert all this thing to the galactic center because nobody cares at T that you're using the 0, from the sun because they wouldn't use it because that's not their galactic center. So I had to convert everything to galactic center coordinates, which is part of the math here. There's a couple databases that have historic hydrogen measurements. And so what you had to do is basically I kept latitude 0, which means I'm on the galactic plane, and I just had to put the galactic longitude, and then it gave you a velocity curve for that point from the history. Now it's interesting that the maximum velocity tends to be the source that is almost tangent, the closest, that maximum velocity the guy closest to the galactic center because it gives you this and it's moving the fastest compared. So realize that it's called the tangent method that the distance to the galactic center is closest to that is the highest velocity you get on your Doppler shift. All these other guys, here, here, and here, are either closer or either here, because it's all along the same line. So either here or they're here. All right? The highest velocity is the guy closest to direct tangent here. So I just realized that that's a theme of the stuff. Okay, now if you measure all this stuff, and this is still coming from this database, you'll find that the rotation curve. So how fast is the sun going around, or how fast is the galaxy moving at the sun's location? And you'll find that it gives you a nice curve here. Okay. Now there's other things here that there's other little subcurves that build up to that, but basically this will give you this database. So one of the key things is that one, you don't know the locations of these points exactly in an XY coordinate scheme. You just know that they are so distant from the Earth. So what I had to do is convert these to an XY, what's galaxy now the center, what's an XY coordinate system of the galaxy? And then plot all of these points. So, I throw this stuff in because there are a couple geeks here that come to me and say, show me all your math and your paper. So I do. So realize this is for the geeks who are going to come to me and say, you missed something, right? I'm perfectly happy to put my math here. So I'm waiting for someone to do that. Somebody saved my bacon last year because they told me that I was off by 0.2 or something. I said, oh, let me fix that. All right, so what I do is I took the data, I plotted it, and I came up with a formula. It says, based on the distance from the galactic center from all these hydrogen points, what would the velocity be in kilometers per second This is just the data points plotted out, but then I came up with a formula for it, because I had to go reproduce it. It's not a great fit, because a lot of the stuff, when you get down below here, it's not really following a flat curve. But everybody hears about the dark matter that's causing the galaxy to move in one, like a frisbee. It's all moving together. Otherwise, it would look like a swirl, like a, you know, you're flushing your toilet, it's a swirl. All right, that's the dark matter point. It's flat past here, but interior, it's not as flat. So it doesn't fit very well here, but when you start sitting here, you start seeing it's pretty flat. All right, which means that between like 4 and 8, by the way, we're at 8.5, we can pretty much predict what our rotation curve is. We're all moving together like in a record, right? At galactic plane of 0, not below or above, right? So if you do that, what I wanted to do is take all of these galactic points here and come up with an X, Y, Z plot of where they are based on the galaxy being the center of the universe, not the sun. Okay, so now I can do a plot. So here's a 0, 0. So I'm looking at these, you know, galactic over here. These are where the galactic points are, based on an XY plot of, Cartesian plot of the galaxy. Just looking, you know, and here's where the galaxy is, and then here's, basically we're right here, 0, you know, 0 here at 8.5. That's where the sun is, and this is where all the other points are that I found. So this is very useful from a galactic navigator point of view, because I don't know what the sun's, I don't know about our sun's galactic coordinate system, but I know I should be able to figure out where the center of the galaxy is and make a common coordinate system for the Vulcans and us. This I threw in there spherical, I had to go use spherical coordinates to come up with some angles, but fundamentally, and this is where I'm geeking out here, this is the galactic center, this is us, and that is keyed. What's the map that says, hey, how can I figure out where I'm at, the distance I'm at, and what's my Doppler shift here, and what would I see here on Earth, and what would I see here? So this math basically will tell you, based on the galactic center, what the math for the Doppler shift would be. This is actually the change in velocity. This actually gives it to you here. So that means that anywhere in the galaxy, I can calculate the Doppler shift where that point would be based on any point, any hydrogen source in the galaxy. That make sense? So all these hydrogen sources are moving around the galactic plane. This point's moving around the galactic plane, but it's not the sun. What is it seeing the Doppler from that point is? So now I can use that as a galactic navigation aid. That makes sense? Anybody really? I was hoping I'd get a couple.
Isn't there enough symmetry there that there'd be 2 or 3 points?
Yes.
That make the same mathematical.
Absolutely. So you have to actually take. You will get hydrogen. You'll get the same Doppler from a number of different points. So you have to take a number of different points to get the ambiguity figures. Yeah, there's a lot of ambiguity issues. So you at least have to take 2 points. And I'll show you how that works. Okay, so where's keyed? And it's Omicron 2, right? It's up here in Eridanus. This is Eridanus, right? And this is where Skip's been concentrating our SETI stuff on, is Eridanus. So you hear all about that. And that's why I chose it, because I wanted to go fly the mission that all the SETI guys were assuming was happening, right? So now I'm flying it. I want to say, hey, what are we seeing? So it's called either Omicron 2, Homestar of Vulcan in Star Trek, Homestar of Riches in Dune. Okay, so it has some mythology behind it too. Okay? So it's just not some star out there we chose. Okay, so where is it in the galactic? So if the sun's here, keyed is right about there. So it's a little north, from 180, not north, but here's the galactic center, there's away from the galactic center, and it's a little off here, and then from an XZ point of view, it's down, right? So it's below us, and it's up a little north, okay? If you go zoom in, so this is now in galactic coordinates, X, Y, and this, by the way, kiloparsecs, okay? 1,000 parsecs. And a parsec's about 3 light years. Okay, but these are, so if you think about that from a galactic center point of view, this we're at 8.5, and keyed is, it's over here, and then from an X to Z point of view, it's down this many parsecs, 0.0035, 1 parsecs, in the X component on this side. Okay, so why did I do that? Because I needed to go figure out, I took that data from the last one, I figured, well, where are my hydrogen points? So just like you're doing VLR flying in aircraft, right, you had to go figure out your points and then figure out what the bearing is to them. In the Navy, I'm using, I was a Navy navigator for that GPS, I mean a real navigator, and these guys put your periscopes up, they get 2 seconds, they got a GPS coordinate, and they dive again. So what fun is that? So I had to go figure out where everything was, use Omega, Loran, all that kind of stuff. So that's my theory there, yeah.
5 minutes.
Oh, okay, so if you have a course, your sun and you're going to key, 25–50% of the travel distance. Okay, I made an Excel plot that basically took all this math, and I said, hey, if I take this, what would be, here's the XY coordinates of everything, of the position I'm at, where I think I'm at, and here's the source data, and then here's the frequency and the velocity shift that would happen. So I took all that. I did it for 2 sources for ambiguity, and I'll tell you why I need that. So you take that and you say, hey, if I'm at this point here, my velocity here for that source would be this, and for the second source, I'd be this. So now I've got 2 frequencies that I can look at, and if they're at the same point, I'm at that point in the sky. So here's your source 1, source 2, you're traveling, and so now if you get a frequency here that says I'm only at 25%, and here it says I'm 35%, if I'm still seeing them both at the same time, I would end up at a point there, which means I'm off course. Right? Because I'm seeing 2 things, and one says that I'm at 35% of my travel path, one says I'm at 25%, but it's still both seeing at the same time, so that means I'm up here where the 2 cross. So now I've got an ability to come up with where I'm at and to tell that I'm off course. All right? And then what do? I simply do a course correction. And then I would keep taking those data. And then you can automate this stuff and have it automatically tell you that you're off course, and you can put an autopilot in if you want. Okay, so velocity indicators. If I got a source here and I'm going this speed, hydrogen is really a Doppler velocity correction. So I can tell exactly that I'm going, if I'm just sitting there, I should see 100 kilometers per second. If I'm at 200 kilometers per second, I should measure 300 kilometers per second, because this is giving me, that's providing a 100 kilometer per second thing there. So fundamentally, I can tell my speed if I know that number. All right? If I'm off course, then I should be able to calculate what I should be, but if I'm measuring something else, I can tell I'm off course. And then I can tell exactly what the components be. So this is, for the real geeks, I can fundamentally tell that I'm off course based on velocity differences and what my speed is in the sky. Okay? And I'm going to go over this. This is what my position was, that this is a great high school project, that where's the Earth based on hydrogen, your hydrogen measurements. So all these hydrogen measurements you're doing, where's the Earth in its orbit? You can track that all along the year using the method I'm going to show in my next brief, right before dinner, right before, when you guys don't want to see math either. Right? So I am, so what are we going to do? A lot of stuff. One is, you want to map the sky better into galactic coordinates, galactic centric coordinates, not heliogalactic coordinates. Everything's about heliogalactic, which means everything's about us. Just like we went back in time in astronomy, back in the dark ages where we were the center of the universe. We did that again with galaxies, all right? So now we got to get back to the galaxies the center, and we have to have a galactic coordinates. Otherwise, we can't fly through the galaxy, all right? So I know why they did that, but you got to think ahead. Also going to do carbon monoxide measurements. That'll also give you a Doppler shift at just a different frequency that can help some of your ambiguity issues. And we want to start taking data, see if this actually works. Okay, questions? All right. Thanks. Oh, I'm sorry. By the way, this is our dish. We actually, the guys on here jumped onto our land and took this thing by trespassing. So we caught them. They're great photographers. So this is the galactic plane. This is during the meteor shower. There's our dish. And that's, I think, Colorado Springs right there. And so that's a meteor. That's the galactic plane. And so we made him a member of the club, and we said we got rights to use all their pictures, right? And they love us, right? So that's how you do it at trespass. Right? Yes, sir.
Just hold up. Appreciation.
Oh, thank you very much. All right, good. Thank you. Thank you. That's it. Within the next couple of weeks, we should be able to finalize at least
Yeah, thanks for helping. Such a big help. It
You can also use dishes, but I use, we're all measuring height. So let's use height. That's not very So what
I know she does. But I feel like
I have mine outside, facing.
I don't know. My name's Jay.
I get a bunch of stuff.
I would agree to that.
But you gotta get it as far away. The one guy knows
Do you have anything else? I mean, I would love to.
So
I don't know if it's raining.
I have my sketches, I have a spreadsheet,
Just bring it.
things like that, and this one's for.
And my Indians. 'Cause I want to put them back in the room. Because they're just wasting space.
now the port and you have.
What about your self-water?
My what? Seltzer water.